día con el link que dijiste y sin problema, pero bueno, por si acaso.
Pues si quieres rápidamente, sí, tenemos un
Venga,
minuto y medio.
vale. A ver, esta es la pantalla que yo creo que mejor se va a ver. Ok, sí. Vale.
Perfecto, va
Sí, ¿no?
perfecto. Sí,
Vale.
perfecto.
Vale, pues voy a parar para que siga todavía la parte del GTPP. Vale, ya está, ya me ha quitado.
Muy bien.
Gracias.
So, hello and welcome, and at least in Europe, good morning to everybody, also in Africa. So it's the last day of our workshop of the Galileo Teacher Training Program. Let's see how many we are. Can I see these participants? 24, so it's still, people will come, will join, hopefully now in the next minutes. So today, the day of today is dedicated to a question that on Thursday morning, our speaker, Markus Kisler-Patik, has already discussed a little bit. All these efforts that we do in researching space or trying to understand the universe, what impacts does it really have on our daily lives? And so we want to dedicate this day a little bit discussing the different aspects of that. And so we start with a very interesting one, which affects all of humanity in the end. It's about the dangers that could come out of space for humanity and for our planet. And so we have here our colleague, Beatriz Gilete. She's a space surveillance and tracking systems engineer. It's a very complicated word. And she works in the Space Debris Office, which is part of ESA's space safety program. And so she will explain us a little bit what is this, what is doing ESA with the space safety program, what is the problem really caused by the space debris, and what are actually eventual solutions for that. So Beatriz, please go ahead.
Hi, good morning, everybody. Good morning, Michael. Thank you for the nice presentation. Actually, you basically saved me 1 minute on introduction, what I'm going to talk about today. So yes, let's jump into the meat. So as Michael report, I will try to explain you briefly all the hazards that comes from outer space that can affect us, not only at infrastructure level for our satellites, but also on ground risks. And these hazards basically comes from 3 different sources. So we have the sun and its solar flares that can affect our atmosphere and satellites and ground infrastructure. We have the near Earth orbit objects that are basically asteroids. And the third one is something that we have caused, which actually is the space debris. So all the satellites that we are launching and the problem that is, I'm going to minimize this. Yeah. So let's start with the program. So the objective is to protect our life, no matter if it's life or assets. And we covered in these three segments. So the space weather segment will be in charge of sun hazards. Near Earth object will be in charge of asteroid hazards and space debris, and clean space, that is try to remediate the space debris problem, take care about the satellites debris. And basically, as you can see in this image, we have several activities that are carrying out in this segment. So we have the space weather providing services, Lagrange mission, that is a satellite that will help us in the monitoring and forecast with quite in advance all the warnings that come from the sun. From the NEO side, we have how we monitor asteroids. So they are building flight telescopes. They are planning as well what is called HIRA mission, that try to understand how we can deflect an asteroid if for some reason it's causing a problem, a menace to the Earth. And then everything related to space debris, which goes from how we operate satellites, like collision warnings, to maneuver the satellites to avoid a space debris, how we categorize and monitor this space debris, and how we can mitigate this problem. So in ESA, we are funded by Ministerial Council, that is happening every 3 years. Last one was last year, and it was succeed, and we got quite an increase in the budget. So hence all these kind of different activities that will try to minimize the risk for us. So let's start for the space weather. So the objective is to detect and forecast space weather events and the potential effects. And these potential effects can be in terms of magnetosphere induction currents that may affect as well on ground, but also radiation risk and the sun and solar winds. All these expertise are gathered in, we call them services. And they provide these services via a hub, that is so the coordination center that is settled in Redu in Belgium. And will basically what it's doing, it's collecting all the expertise from a federal network of space research institutes that are expert in the subtopics of the sun, like solar weather, ionospheric weather. All that information is collected by this coordination center and publicly available under this URL. So you can, I put here the URL so you can take a look in there after the talk if you are interested in. This is not everything is a hazard coming from the sun. We also get benefits of these magnificent auroras. And this is a very nice view from the ISS. We are used to see the auroras from ground. But from the ISS, the beauty is even, from my point of view, much than from ground. We have learned that the sun behaves in peaks. So we have every 11 years the same pattern, and we have the peaks every 11 years. So from hazard point of view, we don't like these points because it may cause, and as I will show you later, some damages. However, from a space debris point of view, we are very interested in these peaks because this will help us to naturally re-entering objects in the Earth, and hence we reduce the space debris. I will link this slide, so keep in your mind later when I speak about the space debris. So, as I said, in 2003, we had a peak of that, and there was a flare, as we'll see now in this video, that reached the Earth, and because it was quite massive corona mass ejection, and it impacted quite heavily, not only in satellites assets. So basically, we lost some satellites, we experienced some reduction on the mission objectives of some others, but also on ground. Some of the aviation air traffic was restricted, and there were some also damage in transformer and even in nuclear power plants. So this is telling us that we should take a much closer eye to the sun and the effects that the sun can cause on us. Take a look in this one. So this is an artistic impression of how the corona ejection reaches our magnetosphere, interact our magnetosphere, and sometimes it can create some induction currents that will cause problems. So far, we have in situ monitoring of the condition of the sun when we place the satellites in this called Lagrange point. So if you see in this figure, it's a point between the Earth and the sun. However, from the video I showed you before, the artist impression, if we decide to put a satellite in this other Lagrange point, and a stable point, we can forecast or help the forecast of the menace coming from the sun, because we will support the in situ measurement together with around 10 minutes, 15 minutes pre-warm that something will impact the Earth. So a space weather segment is working now in developing this mission. They got the approval, and then they are moving forward to the construction of the satellite. Next topic is the near-Earth object segment. So the objective of this segment is to identify asteroids, comets, meteorites, and try and estimate the potential collision risk that might happen with the Earth. We are talking about all natural space objects that are around, that can collide with the Earth orbit. And also it supports on the alarms and how we can mitigate this menace coming from the asteroids. This is a figure that captures all the already detected asteroids. Most of them are here in this region, that is the asteroids belt between Mars and Jupiter. The theory says that this potentially could have been a planet, but because of the gravity of the outer massive planets, this couldn't happen. And then we have this cloud that, of course, is interacting with our orbit around the sun. We have a lot of evidence of this existence. So we have fireballs crossing the skies in the newspapers every 2-3 weeks, more or less. You can see some news on this, but we have as well evidence of impact of those asteroids when they reach because maybe for those the atmosphere didn't destroy them. So this one is a very characteristic one. So the diameter of this crater is 1.2 kilometers, so it's impressive. And it was estimated that the asteroid diameter was only 50 meters, but the atmosphere couldn't destroy it. So this can cause a lot of, this causes a lot of destruction in terms of environment. You may, all of you, remember this one, the Chelbansky in 2013. So this was a massive asteroid. It was only, I think, 5 meters. It exploded at 30 kilometer height. So it was not really very far away from ground. And the energy that it released, it was around 30 times the Hiroshima bomb. So imagine if that could hit the Earth, and Scott, that the atmosphere sometimes help us. But even though it created a lot of damage, and I will. Okay. And this is a video, very nice video, how the effect of the expansion wave affected the infrastructures on ground. Then this table summarizes some facts on how the diameter, how the impact energy will cause a diameter of a neo that that is not destroyed in the atmosphere and enters. The typical interval that we have identified as they are appearing in our history, and the potential effect. So just to relax you a bit, it's like we need 10 kilometer satellite, asteroid impacting the Earth, not even destroyed. But the amount of energy released is super massive, and this could end the human civilization. The theory says that dinosaurs disappear because one of these type of asteroids impacting us. You can check more. I mean, I couldn't update because this is always the demo effect, the number, because the portal for some reason is down today. But regularly it shows you how many known asteroids we know, and they include a risk list of these NEOs, where they are encouraging astronomers to look at them in order to refine the orbit and compute associated risk of potential impact with the Earth. But as I said, most of the NEOs are still unknown, so it's a real menace. How we can mitigate a potential threat coming from a NEO towards the Earth. So there are several deflection strategies, like explosive strategies, or gravity tractor, kinetic or ion beam shepherd methodologies that can provoke a very tiny movement in the asteroid. But as I put in here, just a change with 3 centimeters per second may move the position by 14,000 kilometers in 15 years. So just a slightly impact could save us of a potential impact from them. And here is the mission where ESA is working on, which is the Hera mission. It's a combined mission with NASA. So NASA will release the Dark Impact satellite into Didymos, which is a binary asteroid. And Hera mission basically will go after in order to measure what this impact of this asteroid, of this satellite in the asteroid provoked. And like that, refine our models and think on potential mitigation measurements for future. This is a very nice YouTube video. I encourage you to look after the presentation where Brian May from the Queen music band explained very nicely the concept of the Hera mission. And the other branch where the NEO people are working on is to augment the capacity of observation. And for that reason, they are going to build a network of what they call fly-eye telescopes, because the cameras is going to be a very large field of view telescope, and is composed by 16 cameras, so acting like, if you see this picture, it seems to be a fly eye, and that's the reason why the network is fly eye called. Right now, they are deploying the first of these ones, and in Italy. So in coming months, we will maybe see some pieces of news in the press. And now I'm going to talk about my domain of expertise, which is the space debris. So before starting to talk about the facts, number, how we observe, how we mitigate, what is the space debris? So we need to define what the space debris is. And it's everything that is man-made, including fragments and elements thereof, like this one, for example, that was released from a launch in Earth orbit or re-entering the atmosphere. And this is crucial, non-functional. So since the era of we started the space era with the Sputnik launch, we have already launched more than 5,000 successful launches. And we need to keep a track on those. And so hence we have a catalog of orbital elements from several space surveillance networks. The two main ones are the USA one, that is called SSN, and the Russian one, that they have a network of different types of sensors around the world and monitor and track constantly the objects. However, with the technologies that we have on ground, we can only observe objects above 10 centimeters. and they are publicly available, and it is provided by United States, but it's only about 20,000 objects. And from this graph, you can see that it only represents a very small part of the global issue that we are suffering. So from that 20,000 tracked objects, we have only 6% of operational satellites. The rest is called debris, and it can be because they are already defunct satellites, rocket bodies, upper stage, mission-related objects, and fragments caused by collisions or breakups. It is estimated that this is a very nice video of the evolution of the space debris. So we have it's going to show you how the number is increasing in terms of the size of the objects. So you can see that the most crowded area is what we call the low Earth observation orbit, where all the meteorological satellites and nowadays communication network satellites are being deployed, and it's starting to be quite congested. Then we have the geo region, where all our communication satellites are in place. And now you can see what we have tracked. So this is showing you the current state of the already tracked population of more than 10 centimeters size objects. But it is estimated to be more than 1 million objects for very, very small. I will accelerate the video. So here. So this is the quantity. I mean, we are thinking about that there are particles of between 1 millimeter to 1 centimeter to be around 100 millions of these objects. And if you think that this cannot cause a problem, I will try to show you that it's not the case, unfortunately. This is the current tracked object population. So keep in mind the 10 centimeter size objects. We, in the Space Debris Office, release in yearly basis the current state of space debris, and this chart is extracted from there. So since the first moment we released the Sputnik until now, there are two big events that increased drastically and exponentially our population of debris. One was of the destruction of Fengyun in 2007. This was an intentional destruction, so there was a Chinese meteorological satellite, and they would like to demonstrate that they could shoot a ballistic missile to the satellite and destroy it, and they succeed. However, this caused a 3,000 objects cloud that increased exponentially the population. And the second event was the collision between two defunct satellites, one Russian, Cosmos, and the American one, Iridium, that create a 2,000 objects cloud. And I'm pretty sure that every month you have already read some news in the press. Recently, actually, was last week, of potential risk of collision on between satellites. So unfortunately, this is coming more trendy than in the past. But we somehow are a bit lucky because of the atmosphere. So all those objects that are in the low Earth orbit can be re-entered naturally thanks to the drag in the atmosphere. So this chart tries to show the number of objects that re-entered. What I can just highlight from this plot is that most of them are in the LEO orbit only. So we are somehow releasing a bit that orbit, but it's not the solution. There are, apart from the breakups on purpose destruction of satellites or collisions, there are other space debris sources, like the ones that coming from the solid rocket motor firing that release particles of aluminium, and as well from the coolant release events like sodium, potassium, of other type of engines. But you see the particles are very, very small. Nevertheless, I will show you they are dangerous. we have we could observe directly in situ how these little particles can affect the function of a certain satellite. And when the Hubble Space Telescope had to be repaired of the optic, the astronauts took the opportunity as well to repair the solar panels. And they brought ground pieces of those solar panels that will allow us to would allow us to observe the micro tiny impact everywhere. And this is very useful for us to validate our models because for these tiny particles we cannot observe from ground, hence we have to model them. And in order to validate the models, we need this kind of proofs. So more images on how the Hubble was impacted everywhere, like in the solar rays, even in the antenna. Even the Kepler is also a menace to satellites because astronauts can go outside. Actually, there is one of the debris is a screw that one of the astronauts in one of his walks accidentally released. And so that Kepler may cause problems. This is a reality that we suffer in ESA with Sentinel-1A. So basically, flight dynamics team observe a tumble in the attitude of the satellite. Then it was followed by a decrease on the solar energy they got from the solar panels. And they say, okay, let's do something. Let's try to switch on again the camera that it was only foreseen to be on to demonstrate that the depletion of the solar panel happened correctly. And then they realized that there was a hole here that had been caused by a space debris. This graph is actually very interesting and it shows all the problems in a row. So we are in the x-axis, we are showing the size in logarithmic way in order to highlight the differences of the objects and the number of all those objects. So as I said, for objects above 10 centimeters, we are fine. Somehow we can track them. We have means to observe them. For the rest, we don't have observation. Hence, we have to rely on models like the one that we are using in the agency that's called MASTER. A particle of less than 1 millimeter is expected to be on this order of magnitude. There are a lot of them. And this can impose some surface degradation. If we go between the window from 1 millimeter to 1 centimeter, it might happen penetrations. Between 1 centimeter to 10 centimeters, you can even lose completely the emission or even worse. So these are the threats that we are trying to face with. I mean, we don't have observation. What we can do in this region that may impact severely the mission objectives. Just to tell you the amount of trash basically that we have on above of our heads. So we are counting almost more than 6,000 tons. Of course, everything comes from the larger size objects, but nevertheless, the numbers of the others for the smallers are quite impressive. This is to show you, I mean, this is a on-ground test that we performed on to demonstrate hypervelocity impacts. And basically this bullet of aluminium ejected at this speed, it's the typical speeds of the satellites. You can see how it can penetrate, and it's quite impressive to see this on ground, and you can imagine what can happen to a satellite. And actually this is part of a satellite. Imagine the satellite to have all these 5 seals plugged together, and so the bullet was ejected, and it was even almost to penetrate to the other side, which is the pressure side of the satellite. So if that happened, then you lose your mission. So So how we observe all this space? So we have the sporadic detection and statistical counts based on models or some onboard cameras to model the objects between the very tiny ones until 1 centimeter. And then from 10 centimeter onwards, we rely on catalogs provided by the different surveillance sensors. So we have the one provided by US, but there are some commercial trends now, like Leo Labs, that they are building radars in different parts of the globe, of the Earth. And we can rely as well in some new ones that the ASCAT is building in Sweden. This is the Space Surveillance Network from US, so you can see that they have, most of the sensors are in the North Hemisphere, but we have some of them as well in the Southern. These are the different European sensors that we are collaborating with. So in the optics, we have several in different countries. We have to distinguish between survey and tracking. So this survey type, basically you point your sensor towards a certain region in the sky, and you just wait until something passes in the field of view. This helps you to build up a catalog, but the accuracy of those orbits or measurements are not going to be that nice. In order to maintain the catalog, we need more accurate orbits, and that's the reason why we track the orbit. So once you detect for the first time an object, you have to track it in a more accurate way in order to refine the orbit. The same happens with radars, and with laser stations are mainly for tracking. But for the radars, it's exactly the same. We have survey and tracking radar, and even different configuration of radars. So this is one that we have here next to Madrid in Santorcaz. This one is the OGS in Tenerife. That actually is being shared with the NEO community. So part of the month it's used to try to discover new asteroids, and part of the month to categorize and try to observe objects in the geo region. This is another one, TIRA. This is in Germany, and it allows you also to make images. So this helps a lot in order to identify how a defunct satellite or debris is behaving, because when you lose the control of a satellite, the object is stumbling. And hence, to characterize that attitude motion, we need these support nice techniques. This is an observation from the OGS, so all the characteristics I think is not worth to enter in. But these are the typical images that you get. All these the streaks are the stars, and then you are following the objects and you see it as a point-like image. Another one that we have in Febrero, so here as well in Spain, and it's going to be a second one deployed in Chile, is the robotic telescope prototype. And the idea is to have one in the Northern Hemisphere and another one in the Southern Hemisphere, and try to monitor several times in a day. Not in a day, but I mean, you first start in this night, and then when our site starts the night, you can try to reacquire the observation. So more information about the telescope. These are, as the other one of the OGS, is the same. You can see very tiny dots there, and that are satellites. The rest are the stars. For the radars, there are several techniques. So you can rely on monostatic approach or bistatic approach. And the type of images that you got, they are not images. The type of measurement you got from a radar are actually the echoes. So a radar sends a pulse towards an object, and then it measures the echo. And from that, you can extrapolate how the movement of the object is. So usually this is the typical range curve that you can obtain from a radar. So as the object is approaching towards the Earth, you will have the minimum range. So this is the minimum distance the object was to the Earth, and then how it escapes again. And this is a very nice one with the Santorcat radar that we managed to show in a row a constellation of 3 satellites, the swarms, when they were launched for the first time. So we saw the 3 smileys in the plot that was meaning a success. So, but we need to live with this space debris. So how we model, so we have to understand the sources of the space debris, as I already mentioned in previous slides. We need to create a database where all the events that are creating the space debris are stored. We have to simulate and try to derive object population, and we have to propagate in order to compute the orbits at a different epoch. And for that, we use the master model. The sources of space debris are a lot of them. I mean, since the launch, you have the upper states, the payloads, or mission-related objects. For example, when you launch an observatory, at certain point, the cover of the camera is released. So that cover is a mission-related object, and therefore space debris. Then we have to cope with fragmentation that can happen accidentally, like explosions or collisions, or even other sources like the tiny particles I mentioned before from the different firing sources. But we have some natural sinks that, thanks God, helps us to control a bit the situation, which are the atmospheric drag and some perturbation. So this one, the solar radiation pressure, is that the one is of us, because when we have this peak in the sun evolution cycle, we observe a lot of more re-entries than other periods. And we have now starting to investigate on active removal of the debris. So for the collisions, we have, as far as we know, four of them. So the most critical one was this one that I already mentioned before, between these 2 defunct satellites. But this is starting to be a growing problem. So even, I mean, recently we have seen that we increased the collision warnings. Fragmentation events, only last year we compute to be created, I mean, almost 2,000 more objects just because of the events. And the problem of a fragmentation event is that it creates a cloud. I mean, I can put it again. It creates a cloud when it happens, this fragmentation, and all these tiny objects and fragments created get embedded in the active satellite orbits, posing a lot of problems into their operations. The breakups, this is a chart that I extracted from the Space Environment Report, and which is to highlight is that most of the problems are caused by propulsion. So there are some accidental explosion due to the fuel, and sometimes as well from electrical, like batteries, or that maybe have been affected by a solar flare and induce a current that creates the explosion. But we have some of them that is still unknown. But this is to pay attention. A deliberate breakup causes are around 11%. And recently, I don't remember, it was early this year or last year, there was an intentional destruction test was conducted by India. And they managed to, they thought that just launching a small CubeSat at lower altitude orbits, which didn't interfere with the others, could solve the problem. However, when you impact these sets of very low Earth orbits, then you release some objects above. So even if you think that you are not going to create any problem on the above orbits, actually it's just the opposite. The particles from solid I already mentioned, and this as well. And this is again the same figure as before. So very tiny particles can cause problems, and we have a lot of them. So we are now facing more and more with degradation in the surface and potential loss of the emissions because of the degradation of the solar panels, like the one by the Sentinel one I mentioned before. But we are starting to get to be in a very high number of very large pieces that can destroy completely the satellite, and even worse, create even more debris. So how we operate in this congested and special environment. So we need to understand where the different objects are. And we cannot know precisely. What we can know is the state vector or ephemerides of the position at different epochs and the uncertainty of that. And usually the uncertainty is measured by an ellipsoid. And so the major uncertainty always is a long track. And basically what we compute is which is the collision probability. If the collision probability is above a threshold by the guidelines is around 10 to -4, then we recommend always to conduct a maneuver in order to try to avoid the collision. So this is an example that happened, we conducted in ESA with the MVSAT. It was compute a probability threshold above the T-4 to be collide with an upper stage. Then there were some on-calls with the flight dynamics team, and we told them, please make a evasion maneuver in order to avoid the satellite. So they just file a bit in order to increase the orbit. And then after the simulation, the distance was safe enough and we didn't have any problem. Another problem that we have is the reentries. Most of them are uncontrolled reentries, but some of the satellites like ATV are designed to be re-entered in a controlled way. Like that, we guarantee that the satellite is destroyed in the atmosphere and doesn't pose any problem or menace to the Earth. And this is, a nice record of that. Is the ATV re-entering and destroying in the Earth, so it was no problem on Earth. But unfortunately, there are sometimes it happens that we can find evidence that it hits on ground, and usually are related to the upper stage of the rocket bodies. They are designed in a certain way, spherical and cylindrical shapes. That are hard to be destroyed in the atmosphere. This is that most of the reentries are uncontrolled. I want to prevent you that this is not showing you all the impacts on Earth. It's just all the re-entered objects, which makes a difference. Thanks God, most of them are concentrated around the equator, where the massive Pacific Ocean is, and hence most of the re-entries happens here, so it doesn't pose any no risk to life. This is the yearly re-entry mass per object. So when we have the peaks of the solars is when we have the peaks of the re-entry mass. So it's nice to see that a lot of mass has been already re-entered, but in numbers the vast majority in a controlled way. We make a lot of re-entry predictions. So we have this interagency space debris coordination office where we conduct several re-entry campaigns where all these entities are together trying to monitor till the last moment when an object is about to re-enter. So at the beginning of the observation campaign, the uncertainties in the prediction of the epoch and the place are very, very large. And as we are getting close to the event itself, it helps you to the uncertainty, and you can somehow safely set when it's going to happen. So how we mitigate all these, the long-term consequences. So this is. There is someone with the microphone on. Could you please mute? So we have this Kessler syndrome that actually is a feedback condition. So it's a cascade effect. So if you increase the, I'm sorry, there is someone with the microphone on and it's quite disturbing while I'm speaking.
Yes, a little.
Yeah. Well, I will try to not get disturbed about that. So as soon as we are increasing our launches, we increase the collision probability. And by increasing the collision probability, we increase the population. So it's a cascade effect, and it's called the Kessler syndrome because Dr. Kessler was the first one. He's an astronomic guy from NASA that in the 80s he started to raise his voice to point out this potential problem. So what happens if we continue business as usual, meaning that we continue launching at the same rate that we are doing? We are going to augment these collision probabilities. And if the collision happens, we are going to have more objects. And the trends are exponential. So we have to do something. But what will happen if we decide not to launch anymore and we don't implement any mitigation guidelines? This won't prevent to reduce the space debris population, just the opposite. It will still occur some collisions and the population will still growing. So this means that we need to implement some mitigation in order to try to reduce this problem and not being cut it from getting outside the space to the space again. So the mitigation scenarios, so just in graphs, so it's basically the same as the video. If we implement, I mean, this is if we continue the business as usual, but if we implement some of these mitigation guidelines that I will explain you, then we see that we reduce the number of objects. So we need to somehow to promote these guidelines and application everywhere in the community. So how we can mitigate? There are some parts where we have already reacted. So the meteorites is something that we cannot prevent. I mean, they are so small that you have to live with them. But you can protect your satellite. So you can put some seals in order to limit the impact. We can as well stop the usage of these kind of motors, engines that are releasing these particles, like the aluminium ones. So we can go for aluminium-free propellants. We can even try to limit the exposure time to space. And we can help operation by collision avoidance and by conducting disposals of the satellites. However, this is increasing quite a lot because of the mega constellations of satellites like the ones of Starlink that I'm pretty sure that you have spotted on our skies recently. So we need to tackle this issue because this is increasing too much. And then we can already mitigate the explosions. So we basically, what we conduct now is that whenever a satellite arrives to the end of its life, they have to passivate. And what that means? So the remaining fuel has to be ejected. And once that it happens, then you deactivate your batteries. And like that, you avoid any potential current induced fragments. So this is if we continue. So how the number of objects will increase if we continue to launch as we are. If we guarantee that all the satellites, if we guarantee that all the satellites get the passivation, we are still having a problem. But if we combine that all of them we ensure have been passivated and we implement post-mission disposal maneuvers, we start to stabilize. And if on top of that we add active debris removal, about 5 objects per year, I'm talking about large objects in here, is at the moment that we bend the curve. So there are some mitigation guidelines. So in many standards and regulations, we limit the number of objects that you can release related to the mission, like the cover to the cameras I mentioned before, how you have to passivate the upper stage, you have to move your geosatellite whenever it goes to the end of its life to what we call a graveyard. So basically, we're postponing the problem. We are moving the telescope, the satellite into a upper orbit out of the gravity Earth influence. And there is the limit of the presence in the LEO orbits to a maximum of 25 years. In some of the standards, they go further and they put some limits on ground risk. They give you some guidelines on how to active collision maneuvers performances and limit the release of these nasty engines on the aluminium in the slag and dust. And under discussion, we have the active removal of objects. So the two protected regions I mentioned, the LEO, so you have to guarantee that if you want to launch a satellite in this region, in 25 years, it has to re-enter. And to ensure that, you have to keep a percentage of the fuel in order to perform the last maneuver that can guarantee that. And the geo region, whenever your satellite is about to complete the mission in this region, you have to move forward to the graveyard orbit. If we just some numbers, if this is the typical satellite that we have in the LEO orbit in 800 kilometers altitude. If we have a defunct satellite of very tiny, I mean, this is not this is the typical size of the satellites at that height, it's going to cost 100 years to re-enter. And even the smaller particles, like 1 centimeter, 20 years. So we have to impose some maneuvers at the end of the life of these satellites in order to guarantee the 25 years. For the GEO disposal, we have to ensure that the GEO providers' satellites are compliant with the IADC guidelines. And what we have observed, this is growing. Most of them are compliant, but we are still a bit far away from having the 100%. So we have to still push more guidelines, standards, and rules that will bind suppliers of satellites to be compliant with this. This is a satellite from ESA, IRS-2, that wanted to be the demonstrator how performing a last maneuver will help you to be compliant with the 25 years guideline. So basically, you perform a last maneuver, then you lower your height. Here, going at this height, you guarantee that in 25 years, your object will be re-entered. But during 25 years, it will cause problems, of course. I mean, you have to, it's always a balance. And once you arrive at the lowest point, then it's at that time when you passivate your satellite. So you deplete completely the fuel, and then you remove the batteries. But we are suffering the mega constellations, as I mentioned before. So we are, I mean, actually these numbers are increasing more. They are thinking, Starlink's requested for 40,000 satellites. It's nice. It will provide internet coverage around the world. However, it's causing a lot of problems, and they are quite obscure in the way they ensure that they are doing collision avoidance maneuvers and they have that capacity on board, but they are not really transparent, and it's always causing a lot of problems. And even more, they are not following completely the rules on terms of the criticality of the components. Basically, they have said that 1 out of 10 of the satellites that they will launch, it will fail. So this is telling us that we are going to have a massive problem in coming years. not only in space debris problems, but as well astronomers. Astronomers are quite worried about how this will affect their observation, because nowadays they are seeing in the field of views massive trails of these satellite constellations. But we are working on that, and we are making close collaboration between different entities, agencies, member states around the world. Everything started with the guidelines by the IDDC, and from there several code of conduct was driven by the mainly European agencies. We have derivative requirements. And then we are adopting and evolving the ISO standards and how we can mitigate the debris, but not only in the design of the satellite, but as well in the operation of the satellites in all the phases. So since the design of the satellite till the disposal of the satellite and of its life. And how Europe is as well doing the effort to adopt the ISO standards and try to compile all the mitigation guidelines. Having said this, how we can remediate this space debris problem? So basically, the payloads, the optical solar panels, this cannot be protected. So we have to just rely on likelihoods. Tanks, yes, we can do things. We can passivate. We can remove the field, and it can exploit even though. We can protect the structure with wearable seals. And for unmanned missions, the already on operational satellites can perform collision avoidance, but this has to be limited somehow because this is increasing too fast. So that's at the moment we arrive to implement in ESA the clean space, and it's trying to tackle the problem in 3 areas. It's trying to tackle what is called eco-design, so it means how we can make most green technology in all the phases of the satellite mission. So since the launch, since the design with the materials, toxicity of the components, etc. Till even the launch, trying to minimize the fuel and all the costs that we can imagine. Then the other one is to improve technologies that can help us to have a more eco design, and also try to design for the needs. What this means, to try to use, to invest technology in materials, how guarantee that they will degrade if they go through the atmosphere, and then that you can guarantee that you are not creating more space debris than the minimum required. And then there is the third branch, which is the active removal. So here we need to understand how the defunct object is behaving in terms of attitude, so tumbling motion. So you have to get really very close to the object, try to make a rendezvous. Then you have to capture, so you have to test different technologies that I will show you, and then you have to guarantee the re-entry. So in these active debris removal technologies, there are some of them on study. You can approach to a satellite by LiDAR, trying to reduce the attitude motion, or even by the pressure of a light. And once you have stabilized the motion of the satellite, it's when you can start thinking to get much closer and try to use methods like this one with a robotic arm, or the one that is going to be shown in some seconds, like a clutch or solar sails, or even like harpoons, or with nets like these ones. These technologies has been already successfully demonstrated, the one for the harpoon and the network, by the Remove Debris satellite mission conducted by Airbus. There are some nice videos in YouTube that you can check. and then this will help us to reduce the problem that we are facing by re-entering in a very safe way. But this is still on a study phases. So that's all from my part. I think that I managed to do it on time. So thank you very much for your attention. And in case you have further questions, you can raise now your hand, or you can write me an email, and I will very happy to answer.
Yeah, many thanks, Beatrice. Very nice presentation. I'm always fascinated by the videos, and I'm also a little bit worried by the graphics. With a lot of dots of the debris always.
Actually, sorry. Before I just after the slides, if you are more interested, watch this YouTube video. That is a video that we created in the Space Debris Office to promote. A conference that we have every 2 years. The next one is going to happen next April. Virtually, I will have to admit, and it's very nice. So you will see, actually this is a summary of all my presentation. Just, go to the question, sorry.
So can you see the questions in the chat, or shall I?
Let me open it. Yes, I can show them, but I didn't pay attention to them, I have to admit, otherwise. So I have to go one by one, or?
Yeah, please, if you can. So there's this.
That's actually one of the comments I made, that we are seeing problems with astronomy. And actually, there are some astronomers from ESO, if I recall correctly, have created a report on how they need some laws or legislations that will guarantee dark skies. It's quite a hot topic right now. Clear space, that's it. That's what is intended, the clean space. So that the idea is to be the first service contract to do that. So the people that actually know quite a lot. Sorry, I couldn't hear you properly. Could you repeat?
No, I think it was just a microphone.
Okay.
No.
Yes.
Yeah.
Okay, so I think I couldn't see more questions. So
no, I think this was most of it. I personally always have the question, because I'm really worried about this large constellations like SpaceX or
Starlink.
Because as far as I've understood from your talk, there's nothing to regulate them for the moment, no?
There are regulations they had when you are the manufacturer of a satellite and you want to put something on orbit, you have to request permission. And in case of United States satellite providers is the FAA. So the Federal Aviation Administration, and they got a green light. However, they are now trying to mitigate how this will impact. And there are some. Actually, there are some nice discussions at political level, because this always is try to balance the government implication with the commercial, and the trend is on the commercial side right now, but we need to put regulations. There are some countries like France, for example, that included in their set of laws as a country some laws on space debris. So we are moving forward there, but still a lot to do. Then you have to trust the satellite manufacturers if they tell you that they plan to build such a constellation, but with certain guarantees that they will cover certain risks, then you have to trust them. So it's a balance, but of course a lot of things to do still legislation. But there are active working groups, and in terms of standards, there are a lot of effort in there.
Okay, Beatrice, many thanks again.
You're welcome.
So let's go to the next topic, which is...
Michael, it is another question in the chat, the last one, I think.
Why not using something with origami? For me, less debris. It's not a problem of volume, actually, or actually it's even worse. I mean, if you remember some of the graphs, the smallest pieces are causing the most danger. So even for, I mean, and actually what is happening is that we are facing a miniaturization of the space market. Before, at the beginning of the era of space, everything was big satellites with very powerful payloads, and right now we are moving to smaller satellites in constellations. And try to decouple the different payloads around the network, and this is causing more, CubeSats, for example. That's it. So, and this is causing even more problems. Because with CubeSat, you can, I mean, there are some efforts now in technology level on providing them maneuverability with little engines. But usually these kind of satellites cannot maneuver, so you cannot avoid any kind of collision warning. So actually, the smaller we get, from my point of view, the most risk we have to cover.
Okay, many thanks. So let's go to the next point.
Okay, thank you. I will. Yeah.
Yes.
Thank you, everybody. Bye-bye.
Bye. So we're going to a practical approach now. So after this very interesting talk, we are going now to something that you can do yourself. And so we have our colleague Manuel Castillo here again, and he will show us what you can do with Earth observations for society, which really affects you and your surroundings, with Google Earth and the other tool, which is Snap. So please, Manuel. You're muted, Manuel. You're muted.
Can you hear me?
Yes, now we can hear you. Yeah.
Well, so good morning, and well, first let me share the main tool we use, that is Google Earth, to show you how to use Earth observation data to to explain many of the things, or to put in context many of the things that happens and affect the society. Well, let me share first. I optimize this for motion because you will see that everything moves a lot. And this is okay. Okay, I remove my, I mentioned the video. In case it had problems, I will finish. Well, here you have a Google Earth. So we showed you some other experience the days before with Google Earth. And what I recommend first is, if you want to fully enjoy the performances and the possibilities of Google Earth, to install the app. The app is provided by Google, so you can download it. In this way, you can avoid this kind of advertising that is appearing from time to time if you use it using the web directly. So I encourage you to install Google Earth Pro. That is something that is provided by Google. You have many groups providing information. You have many guides and many tutorials in YouTube, in PDF. You have a lot of information in order you can use freely this tool. Well, technically, Google Earth is a geographical information system. This is something that has been used from the beginning of the remote sensing and the observation to combine imaging data taken from the space with another information that we know, like borders, streets, this kind of vectorial information that can be very useful to analyze the data we obtain from the space. Google Earth for sure incorporates the data, incorporates all these kind of layers you can use. You can put everything you want following the instructions that you have. And well, it's a very friendly tool also. It's not like the professional geographical information systems that are very complex. In principle, everything that they will show you that can be done with Google Earth, some examples, I will show you some examples, in principle can be done also with professional tools. And you will see that you have many advantages to use Google Earth. And sometimes, you have some limitations that can be only overpassed using something more professional. If we have time, I will show you how to use Sentinel data, and so you freely can obtain data from any time and at any place in the world freely to use for your purposes. So later it can be incorporated to Google Earth, or you can use it in another way. Well, let's start. So for sure, Google Earth is we have a space data. We are observing the place where we live. So this is the context where our society is developed and everything. So first thing you can see is to overlap data and to go around to see the space, the context where we live. So here I have some examples connecting with the presentation by Beatriz. Well, we can show, for instance, the impact craters. I have a list here that you can obtain on the internet. And I don't know if this, can you see this properly?
There.
Yes? And the movement and everything?
Yes.
Yes, perfect.
Okay. So we have here some indicators. You cannot see many places where we have impact craters. Impact craters are craters caused by external objects. So, near Earth objects, meteorites, these kind of things that impacted on the Earth and they leave a crater there. Well, in principle, there are not much because the Earth is so dynamic that everything is due to the plate tectonics and the other geological events that are happening on the Earth's surface. Normally they are removed. So we have only information. We have only a few small craters because in few million years they are eroded, they are removed, and information about very huge craters. I can show you very old craters that we have in Canada. They can be seen here. This is a very huge crater. Using the tools that were shown by Beatriz before, we can measure this crater. And we have a diameter of 60 kilometers, so it's something very large. It has been inundated by water. You can see how they evolve in the context of the tectonic plate where they are. But we have these twin craters that you can measure also, and you can see that they are a diameter of 60 kilometers. They are very huge. So we have around only 100 that identified around the Earth. But we can go to the most famous one. It's the Barringer crater that is in Arizona. You can see it here. This is a small crater, also a recent one. You measure the diameter. Is the longitude also in the floor of the crater, but you have a diameter around 1 kilometer. It's a small crater. And to show the different morphology and everything, you can play and you can rotate them, and you can show it. And you can see that this is a very recent crater. You can go crater by crater, impact crater by impact crater, and so this. This is one of the elements that in some way connecting with what's explained by Beatriz. Normally, we don't expect many huge craters from now, but Well, why they are removed? Well, they are removed because we have something called plate tectonics, so the continental drift. So we have different plates in the Earth. I saw this before when I explained the GNSS system in a previous talk. And well, you can see they are the intersections between the different plates, and due to the drift of the continents, of the continental plates, so they are intersecting, you have different types of interaction. And this is interesting because, well, as I showed you before, volcanism and seismology activity happen here normally. It's going slow, it's charging the earthquake. I show here the earthquakes for 1 year, one complete year, and the volcanoes. And if we go here to Europe, you can see that all the volcanoes and all the earthquake activity is linked to these intersections between the different plates. Let me see, going slowly, but here if we go close, you can see that all the volcanoes are distributed along these intersections, these interactions between the different plates. So in this way, you can explain what are the most seismological risk areas and these kind of things. But you can see that all the volcanoes are here. Also, for any volcano you want, you can go there. This volcano, a Tepi volcano, for instance, is a arbitrary example, a random example. You can go here, you can go around, and you can see the different morphology of the different types of craters and this kind of thing. Also, this you can find this kind of lists in the internet. You can see the type of volcano, the altitude, and many other things. Also, you can go for explain a particular geological effects. This can remove everything because you know everything is very slow. Okay, we can go to the dry valleys of Antarctica. Even if you have in Antarctica, you have a lot of ice and a lot of precipitation around. There are few dry valleys in Antarctica where the precipitation is very, very low. They are the most significant, how do you say, reference or places in comparison with Mars. This is a terrestrial analog with Mars. It's an area with a very low precipitation, very cold, and well, you can go there to some people is going there to test the rovers and this kind of technology that later is going to fly to Mars. You have here, and you can explain this. This is related with the morphology around and this kind of thing. So you can use this to describe the geophysical environment we will live. And how this, this is the context where the society, the people live. So what you can see with that. So, let me look this. So you can see catastrophic events related with that, for instance, with earthquakes. So we can see, for example, earthquakes of Nepal, or the Himalayas in 2014. We can see this is the center of Kathmandu. There is a tool very interesting. So you have this. This is something like a clock, a small clock. If you activate this, you have access to all the history collection of data of images that are provided by Google. So sometimes in few places you have a coverage at least of 30 years. But in this case, if we go again to this place, move. But here you can see this is the center of Kathmandu with a few temples and few monuments. And if you go advance a little, you can see this is still before the earthquake. Before the earthquake, with a lot of people around. This is a very touristic place. And after the earthquake, you can see that everything has been destroyed. Well, in this case, you can see the image is slightly different because as this is the first image just after the earthquake, Google introduced this one, and you can see that the vegetation is red because this is an infrared combination of images. But well, you can see the destruction produced by the earthquake, and later you can see the reconstruction. Sometimes you have images with clouds, but you can see that, well, 1 year after, everything was being reconstructed, and now, well, it's more or less, well, many historical monuments were destroyed, but, well, at least they tried to reconstruct that it was. But you can see many places that this happens. So you have a catastrophic event caused by the earth, both the atmosphere and the earthquakes and the volcano. And later you can see that the humans reconstruct the places sometimes very fast. We can go, for instance, to a tornado, the effects of a tornado. The States. If you go before, you can see a lot of urban development here in the American wildlife, you know, this kind of small houses with swimming pool. And one day, not yet, a tornado passed and destroyed everything. So you can follow all the track of the tornado. You have the images here, well, to show what well, the effects of that. This is the track of all the tornado. Also, we can follow the effect of the very huge storms and weather, extreme weather. This is in the Pacific. This is in the Pacific. Let me have to choose the dates. This is in the middle of the Pacific, and well, one day a typhoon was formed in the middle of the Pacific and passed exactly on the top of this island. These islands were in the middle of this trajectory. So here you can see that this well is a place where people that is living in some interaction with the forest, so they are very green islands, but you have this, well, they have their normal life. You have this, 2017, and in 2018, go. Now, you can see that the typhoon, well, destroyed everything. All the forests has disappeared now, and all the houses are destroyed also. This is after the pass of typhoon. So you can see the effects on the society of the different catastrophic natural events. Later we can see that also the artificial ones. But this is very useful, well, to explain that. And later to see is very instructive that later you can see that everybody is reconstructing everything. Not here because this is very recent, it's 2 years ago. But you can see the reconstruction process. We will see later. Well, so it can be used to explain history. For example, let me remove part of the data. For example, you can go to Pompeii, one of the Roman cities, most conserved city, well-conserved city. So you can go here. You have also the 3D reconstruction of the different, the different archaeological places related to. And well, you know that it was destroyed by the volcano, so you have also the volcano here. It's in the other direction. It's not reconstructing very well, but let me do it. Yeah. So with my mouse. Here you have the Vesuvius. And if you put Pompeii, can do a pass with the tools shown by Beatriz. This example from here, passing in front of the volcano. Not this one. We do again. And you can see the volcano here, and Pompeii was on the right. And well, so in some way it helps to explain what happened. So at the end, it was a pyroclastic cloud that was ejected by the volcano, and gravitationally following the lower slope went and it arrived to Pompeii and the surrounding area. You can use this to explain what a phenomena affected in the past due to the physical context. In this case, the distance between, because it was very close, it was 8 kilometers, the distance between the volcano and the city, and the difference of altitude of the two places. Well, it can be used, well, you can go to another places, and you can use this. Internet is full of news about people that have discovered analyzing this kind, with this sequence of images, analyzing the data or places with Google Earth. They have discovered archaeological places. So if you look for news about, you will find a lot, because a lot of people are spending time playing with this data, looking for archaeological places. But I can show you one example that you can use in your class, and you can do in any city you want. So you can analyze the human development of the urban development of the places where you are living. So I did it with Barcelona. Beatriz showed you how to write, how to draw, what to do, to create polygons, to analyze the different surfaces. I did it before to save some time. And we can follow the evolution of the urban development in Barcelona, for instance. Here, the origin of the city is a Roman city close to the sea, so close to the harbor. And later, it developed it. Well, you can do these polygons only analyzing the pattern of the different cities, of the different streets, and the different houses and everything. So you can, in this case, you can recognize the Roman area because it was surrounded by Roman walls that can be identified in the images. So you know that the Roman city was here because we can identify in the pictures things that allows to recognize this. And later you have a different pattern here and around. This is the Middle Age Barcelona, is the place where the city was growing. And later in the last centuries, you have that the growing of the city is increasing a lot. Always from the main communication point that it was the harbor. So you can do it. Paris is another place very interesting to see. It's another place where you can recognize very well for epochs the different parts of the city. And I encourage you to do this in the class, so you can explain history with this kind of analysis of the Google data. But not only that. So there is something that now is very critical that you know that is in the political agenda. It's something that another conflict between science and politics. But you can analyze it in your own, the environment effects. So, for example, everybody is talking about the climate change. So we can go to Iceland. You know, in Iceland we have glaciers. And we can see how they have evolved in the last year. So, for example, this part of this glacier, we can put the clock as before. We can show the glacier in 1984, and we can put here a mark. And if we go now to 2020, 2016 now, reference is removed. Yeah. We will go in the contract. Now it's in, yeah. Well, the combination is not so good. We can compare directly with 2020 now, okay, 16. We can mark here, this is the limit of the ice. We can go to 1984. And we can see that the difference between the front of the glacier in 30 years is nearly 2 kilometers. So this is something that you can measure here. Even worse, if you go to another part, because it depends also on many factors. But if you go to another glacier here, this one, like this. We go first to the glacier. This glacier in 1984 was arriving here. I can put a mark here. And we can go to 2016. Well, in this case, 2019. Oh, come on. Well, I mark here. And you have a difference of 6 kilometers. So in 30 years, the glacier has retreated nearly 5 kilometers and a half. So something is happening here. All the glaciers, if you do this in many places in the North Hemisphere, you can see that this is happening everywhere. So there is some kind of reality that you can check within this. But it can be only here, maybe, but not if you go to Patagonia, on the other side of the world, with the glaciers in Patagonia, you can see the same. Well, I would not do, but you can see the difference between now and before. And you can measure distances in the order of 2 and 3 kilometers. So, well, at least the retreat of the ice, the heating of the retreat of the ice, to associate this to the CO2 and the anthropic activity, the human influence, well, maybe you need to do many more analysis, but you can see that something is happening to the ice around the world, and you can check it with that. In this context, if you go to for example, to Siberia. You know, in Siberia, part of the soil is permafrost. Permafrost is a combination of land and ice. Well, due to the warming of the planet, this ice is melting and the terrain is moving and is opening and is flowing. So this is a place that is called Batagaika crater. It's not a crater really, but this is caused by the fusion by other reasons. Also, it's accelerated because they are deforesting also. But well, this is caused by the melting of the permafrost. And if you compare 2004 with now, you can see that this is increasing a lot. So the permafrost is melting now in the same way that the glaciers. So it seems to indicate that the planet is warming. So, well, later you can interpret and you can cross with another things. The complex is not, the problem is not so easy, so simple. So it's very complex. It is related also with our action on the surface. So, well, the deforestation is very important. An example of deforestation can be seen in Brazil. This is very impressive. We can go to a image here for this sample. You can see this is an area in the middle of Mato Grosso in Brazil. And as you pass the images, you can see here that you can see in these areas that something is happening here. So the vegetation is disappearing. We are replacing the jungle by fields, open fields, well, to produce crops and animals. So here you can see that this is advancing. Practically, when you arrive to 2015, a little more. So practically 70% of the jungle in this area has disappeared. So, and well, with the role that the vegetation has in the control of the climate, at the end, this also has an effect. Not only the CO2 emissions, also this. So, I can show you an example from Spain that is El Ejido. Is where most of the vegetables are produced for all Europe. Is this area. They are, this is irrigated. They are using an aquifer that is below, that at the end it will finish. But this kind of white points you can see, they are greenhouses. From 1984, you can see a continuous growing of greenhouses up to the level that everything is covered by greenhouses. This has a main problem, at least the water management of this area. You have not water for drinking for the people living there. All the water is used to irrigate crops that later are distributed to all Europe. This is in South Spain. So you can recollect 2 or 3 times during the year that this is not normal. You are out of the seasons completely, but you can, you can provide tomatoes in winter for Finland. So, and there is an economical, and you can see that, well, it's something that's from the space and can be very well seen. So in this image, you can see perfectly here the area where we have this kind of crops. So you can see with Google Earth the effects of this topic, and you can take your own idea. So you can take the images, you can compare, and you can go around and see the variations, and in your own, well, you can analyze and you can understand if this is real or not real, and you can interpret and have your idea. So in some way, this kind of tools empower the people to do that. So you don't need an official explanation. You can go here and see the difference between the images. You can verify that this is correct or not. A very well known case is Chernobyl. This is the city of Pripyat. It was the city close to the central station. You can see that now it has been invaded by the vegetation. Nobody's living there. So at the end, nobody's deforesting and modifying the vegetation here. And you have all the city covered by trees. If you go to the central nuclear plant, here. And you can see the historical images. Well, you cannot go far from 2002, but you can see the state of the power plant in 2002. They started to have problems also with the confinement of the nuclear material here. They have a lot of radioactive spills, so they decided to build a new sarcophagus to cover this. Well, you can see that in the images. This image is in 2015. You can see that here they start to do some kind of construction. They are completing. This is a full coverage. By now, is the structure, the largest structure in the world now, metallic structure. And later they move, and later they finish the. And now the reactor, the Chernobyl reactor, is under this cover that will be like that for probably 50 years. It's planned for 50 years. So after 50 years, we'll have to do something because the nuclear activity is continuing. But you can check that, they say, we are going to do a new sarcophagus to cover this, and you can check with that they did. And with the dates, they did it. Well, also it can be used to, I go a little far, for human rights. You can show the effects of the war. Also, we go to Aleppo, it's one of the cities in Syria. You can see the evolution of the war and the impact on the population on the war. Before the conflict that is lasting a lot now, you can see that it put this area, for instance. This is the center of Aleppo. This is close to the citadel. This is a very touristic place. It was a very touristic place. I don't know now. They are recovering the activity. But this is the center, the historical center of Aleppo. So you can see that as the conflict is advancing, sometimes you have clouds in the news. Well, still the conflict was not here. But at a certain point, you start to see that things have been here. Here, the conflict starts, and you can see that all these parts of the city are destroyed. You can see here cracked craters. Look at this mosque. It survived part of the conflict, but at the end it was destroyed also, but you can see it. You can see that this sacred place, preserved place was maintained at a certain point. So they destroyed completely. We find now a crater. And now you can see that, the conflict at a certain point finished. And now they are recovering. You can see different places that they are reconstructing. But especially you can see that the vegetation is invaded in these places, these destroyed places. You can see that the vegetation is invading the craters and everything. And now the crater is full. They are reconstructing the touristic part, at least the access. So you can see the effects of the war and the conflicts, and you can track in some way the development. Another very impressive, relating with human rights, another very impressive place is this one that I will show you. It's in Bangladesh. Well, I go directly to the most impressive area. In this year, you can see this is a very wild area. You have nothing here. It's this kind of jungle that they have in Bangladesh. You can see during the years. This is not maybe the human pressure is advancing and deforesting a little. Yeah. But you can see that this forest, this natural area is more or less conserved. But at a certain point, in 2017, something started to happen. You can pass year by year. Very fast. It happens very fast. You can see that this area, this natural area, is being destroyed. You can see a lot of, the area has been completely deforested. And now you can see here that, some kind of settlement is here. This is by now the largest refugees camp in the world now. This is the refugees camp of the Rohingyas. I don't know how to pronounce this name, but is this ethnia coming from Burma that they refugee in Bangladesh. 1 million of displaced people is practically living here, and they destroyed this area. It's all this area. This is the largest refugee camp in the world. If you go to the past, you can see that this was a natural area. In 2 or 3 years, it was completely destroyed by the pressure of the population and caused by a political issue. Also, you can use it. We can go to North Korea. There are some human rights organizations that are doing this of concentration camps in Korea, North Korea. This is one of the examples. And you can see also the evolution of this area, if they are growing or not. You can in some way control the development of this concentration camp. Well, let's go to look for another more recent event. For instance, the California wildfires of this last month. Well, if we go to this area, it's a wildfire that still is active after 1 month. It started in September 4th. You will see it was this area. Well, but you can see the most recent image you have is 2016, and it's an area in the States. This area, maybe this is this green area you can see here. They are affected now, but you cannot see the fires. So this is a problem. So in some way you are conditioned by the availability of the images. So Google Earth, I don't know the data acquisition and delivery by Google Earth, but they are not providing data in real time. If you widen the nose, you can see that in the past, you can check the evolution in the past, but not the evolution last week or 1 month ago, because sometimes they are not providing these images. In this way, you have to pass to another strategy. So, in principle, as I said, Earth observation data empower the society. You can check what is happening around the world, but you cannot be limited by the availability of images of a private company like Google Earth. In this way, we have Sentinel. I don't know the availability of Sentinel in all the world, but I can show you the links. Copernicus is a European program that is providing not a very high resolution data, but data for environment analysis that is completely free. is covering in different with different systems. Is well, sorry, I got this by a message. You have data for different wave longitudes. You have satellites working in radar, satellites working in high resolution and not very high resolution, but high resolution in optical, and also regional images for weather analysis and these kind of things. And this data is available. I don't know the availability. I think everybody can subscribe in this web page to have access to the data. Yes. We are doing a lot of check-ins. So. And if you enter here, you have all the available data, the data they are providing, but the only problem is that you have to subscribe. I think this is open to all the world, but I don't know if they apply restrictions to non-European countries. Well, if you open a license here, you enter in something like that. It's a map where you can select the area of interest. You can select this area. This area is the area of this fire. You go to the search, sensing date, for example, the last, well, a little more, the last 2 weeks, and sentinel-2. And we look for the available images. Also, they did not. No. Bien, sorry. Oh, I have to access here. Now again. Oh, come on. I'm sorry for that. I selected the image previously in order not to spend more time here. But well, we can mark again. This is the typical way to acquire major satellites for professional projects. So it's interesting to see how it works. So now, let's see. And later you have the images available and the dates, and well, you choose one of the images, and well, there is a problem. So these images are not so friendly that the ones by Google Earth. So you have to process the images in some way. But well, don't worry. So ESA is providing the tools you need to do that. Well, let's wait a little. We have at least 5 minutes to show you. Well, I can, meanwhile, the selection is done. I can show you. We can go to the tool. Oh, going very slow. Or maybe I can remove Google Earth because everything is going very slow. Google Earth is quite demanding. Okay, here you have the list of images and the coverage. So you can go day by day. We have a lot of images, and you have here the area covered by each one of the images. If you want the details of the images, you open here. If the system wants. Meanwhile, I can launch the application. And here you have the image of this area. In this area, there is no forest, there are no fires. Okay, we'll remove this. Oh. I don't know how to go back. Okay, snap, I have a snap here. Okay. Well, it's the last thing I show you. So you have to pass to something more professional, more complex. The learning process is slightly more complex. Well, it's more complex because Google Earth is very easy. But well, if you do this effort, you have a lot of information about how to use it. You have all the manuals, all the information, and also you have this tool. We have to wait. Sorry, it's very slow. Well, maybe we can go to the questions if you want. Meanwhile, this is what we have. Mostly slow. And I have one of the images with the fires in order to see. I don't know why it's going so slow. We'll remove something more.
Perhaps in the meantime, Manuel, you can answer one of the questions.
Yes, yes.
Because,
let me share the image. I am now. Yeah. Is this image? Okay.
Because of course, it's the typical question is that you've showed a lot of those very interesting things, and you have pins there so that you can find them. And the question is here, because if people open the Google Earth Pro, they don't have all those pins because you were putting them together, so they're not there by default, no?
Well, they are available. If you do a look for the topic you want, you put the Google Earth, sometimes you find this kind of list. I can provide you them, no problem. But for sure, you have to prepare the places, or you have to have some interest in the places you want to go there, prepare this kind of show.
So I think that is why I think would be really nice if you could give because I think they can be all put into a file that can be included in afterwards.
Yes.
Because
well, I obtained this data in the internet, so well, there is nothing that is.
You can share the KMZ, no? You can share the KMZ.
Yes.
Yeah,
Yes. Is what I am saying. So why not? You obtained by internet. So.
Yeah. So
well, it is low, but well, I hope that in a few minutes we can see the image.
So the answer to that question is yes. This excellent compilation of places that Manuel has showed here. So he will generate a file that he will put onto the grasp server where you can download it and you can then just load it into Google Earth Pro, and then you can see all those places that Manuel has prepared already for this presentation.
But now let's see if we see the image. The problem, as I explained before, is that you have no control about well, the images that are available. So, but the only way to do that is to obtain a Sentinel image and to know how to superpose this image in Google. That you can. It's explained in the tutorials. Come on. I have problems with the computer. I don't know why. Many things are being. Well, no, if you use Sentinel data, you are free to obtain information as it is available for any place of the Earth at any time. You use the radar images, even you can have the images independently of the weather and this kind of thing. And here we have the image, and I can show you the fires. One ago. Here, for instance. So later you can superpose this image in Google Earth. Let's see until it is shared. And measure, compare, do a lot of things. So, and this is provided to everybody to be independent on the, the official delivery of data. So everybody can do it anywhere and at any time. So the only problem, or maybe the only difficulty, is you must to register in the data provider that is Sentinel. But here, I put this infrared combination in order to show you see the real burn area. So this bluish area, this bluish area is the burn area. So the fires are still alive. This wildfire is burning since September 4th. So they are controlling now 60% of this fire, but well, still they have a problems, and you can see it here. Maybe for comparison with a normal, here you have more possibilities. This is a professional tool. So you can, let's put a natural combination of color, and you can see that the fires are not so clear than in this image. But you can learn how to play with the different spectral bands and do the combinations to look what you want. So in this case, we are looking for contrast and the burn area. So this is the, and I finish. Here you cannot see very well the difference between the burn area and the vegetation because both they are dark. So this vegetation is dark because it is natural forest, natural boreal forest, and you cannot see very well the difference. But if you go to the other image, you can see here very well the difference between the burn area. So this is providing a lot of more opportunities to do analysis of things affecting society. Well, this is the point of view I wanted to show you. So that's
yeah, many things really is another very good example of all the tools that we have available now through the internet. And yeah, we just have to know about those tools to use them. And in this case, it's more related, it's not so much related to science. You can also do science with it, but it's affecting really our daily life. So you can check on things that if you hear something in the news, you don't have necessarily believe it, just go and check yourself. So let me just look if there are some more questions. Now I see a lot of thank yous. No, I don't see any other question. Okay, so then many thanks again. Let's have a short coffee break of 15 minutes, and then we are back again with, after the coffee break, yeah, with Rosa and the space in our daily lives. So let's have a coffee break, and we are back in 15 minutes, please. Many thanks. welcome back after the coffee break. I see always the nice images that Viti is putting on the left side. It's always nice. And we have also here, so we are going to the third part of this day, this morning. And now it's really even more into what space gives us for our daily lives. So, Rosa, please.
Thank you, Michael. It's always very hard to me to take the stage after nice presentations like this one. I have so many ideas in my brain right now of things that I should have added, of things that I should have said. But yeah, I'm really glad that we are having such great quality presentations and so many great ideas. I hope that you guys are feeling as overwhelmed as I am. So I'm going to share my screen and hope that I manage to select the right one. Okay, so can you see my PowerPoint?
We see the whole screen.
The screen, great, but with the PowerPoint, right? Okay, so I will start. Okay, let me just leave this prepared because it's here. Okay, so the objective here was mainly to discuss and to present to you a little bit what we can do and what should we do in space with our daily life, and to empower you a little bit to convince your students that space is it's a very nice place to be, it's a very nice idea, and that they can help, of course, with your guidance, create awareness about our place in the cosmos and the importance of exploring the universe around us. So this presentation is prepared. We are lucky enough to be part of a project called Our Space, Our Future, where we are trying to bring awareness about careers on space and how space exploration is important. And so this PowerPoint is presented in that direction. But it's more or less what we try to do when we are in school, working with students and with teachers. This is more or less how it goes. So the first thing, there is a Padlet that I would like you to go to, and I will put the link on the screen in a moment. And what I want you to do is, first of all, if you don't know Padlet, you will get acquainted with it. Padlet is it's a tool, an online tool that allows you to have students post. Close this. That allows you to sorry, let me just copy the link. Where do I copy the link? The clipboard, and then I have to find here the chat and put it here. So here's the link to the Padlet, and you just enter. I'll put here the QR code as well for those of you that have QR code reader in your mobile phones. So Padlet is a very nice way to ask students to collaborate with you. It's very good for community building, for team building. It's a place where people can. It's just like digital post-its. You can have a brainstorming, and students can put their ideas there. They can share like what you have been doing or what you have not been doing in Google Earth. You can post pictures of things, or it's a collaboratively digital board. And that is really a very, very good to interact with your students. They can do that in an anonymous way. And so it's really very handy. So I'm going to close the QR code. And what I want you to put here is to tell me what are the careers that you think are exist in space exploration. Just write a post. You just click in the plus button here. You see here a button. You click here and you write astronaut, engineering. I didn't write it right, did I? Engineering. Oh my God, I don't remember how to write that. Just write which are the professions you think exist in space. And actually, I can go and say, okay, Marina said astrobiology. Great, I vote for that. I like that. Engineering, astrobiology, astrophysicist. Great, I like that. So you see, at some point, you can make a pool and ask your students what is it that they like more or less, to give opinions, and they can vote, and you can start lots of discussions into the introduction of the inquiry methodology here, okay? So, okay, I want to see more. Don't be afraid. I mean, if you make a post with nothing, or if you make a mistake, that's absolutely okay. IT, cook, okay, communication, education and outreach, yes, very, very true. Space law, very true. Physics, chemistry, okay. I want more, I want more, I want more. Okay, let me see what else is coming. I see that you're being active. Okay, I like that. You're more active here than in Google Earth. Technicians, right? Data analysts. Mathematicians. Okay, you see, this is getting populated. Awesome, awesome. Doctors, okay. Okay, 1 more minute to go. Search for asteroids. Yes, well, yeah, an expert in asteroids to avoid the spacecrafts to bump into an asteroid. Well, actually, sometimes we do want it to happen. I will show you that in a moment. Okay, you're just going to the basics. Architect, okay, like that. Informatics specialist. Okay, so let's see what I have for you. I will leave it open. You can continue. I will put it in presentation mode again. And this is the list that I have for you. I hope this is not in the way. And this is just a partial list, okay? Not even to begin with. There's so many different things that we can have. Let me put it down here. Okay. So, you know, you need an accountant. You need, you can have archaeoastronomers working with you, or have astronaut wives. Well, it's because astronaut is so important. You can have, you need audiovisual specialists. I mean, all those animations that you saw, you need an expert in audiovisual to do that. You need a communication expert, you need a computer engineer, you need a cook, you need a costume designer, you need doctors, Earth observation experts, economists, oceanographers, packaging experts, payload specialists, phone operator, photographer, physicists, secretaries, public relations, psychologists, quality control, radio operator. I can continue forever. I think it's difficult to say which are the professions that we don't have when we are talking about space exploration. So if you are handling students in your hands right now, chances are that they will have a great probability in ending up in some space exploration related career, because there's also all the industry that serves the purposes of space, that create pieces for space, or even, you know, a nutritionist can be creating some very nutritious, innovative food that will serve astronauts very well. So, you know, the cascade effect of space exploration is really, really very big. You have also a few pages. As in the previous one, I will leave this presentation for you. You will have it soon. You have a page in the Zero Island where you have lots of tips or real people that have a career profile. You also have another page from Space Awareness where you have a booklet for space careers, and you can use this just for these things as food for thought to have your students understanding what is the importance of space, or how space can be something for their future careers, right? Now, in our Space Our Future, we are very worried about bringing the very nice idea of what does it mean to be a space exploration expert, but also to avoid stereotypes, to avoid gender bias. So the team created these pretty nice animated GIFs, and guess what? They are yours. I created a kit that's now available in the campus, where you have this and other things that I'm going to share with you to use with your students. So this doesn't portray the typical scientist with Einstein looks and with a coat on. It's just normal people. You know, we scientists are just normal people, as you have been seeing here. It might not seem so, but even, you know, Bea, Naira, Fraser, Michel, they are normal people. They have lives, they have dogs, they have kids. You know, we have life as anybody else. It's just a profession like any other. And this is what we are trying to do with this material. And all this material you can freely use. It's yours. Please use them to enrich your lessons. Share them with everybody else, okay? We also have a collection of icons that you can use in your presentations and everything else from our Space Our Future. They are all in the kit that we have prepared for you. And they are very inspiring. And as you see, they are also trying not to introduce stereotypes, not to send the wrong message about what is space and what it entails and what is the super person behind that astronaut suit. You will also find one tool that helps you create an avatar. The tool is not that perfect because it doesn't have all the to create people, especially it doesn't have the possibility to create people a little bit older. So I did my best here. Please don't scream at me, team. I really hope I don't harm anybody's feelings here, but I try to portray the team. So you see, I think the best one is Naira. What do you think? This is Naira? I want you to tell me how bad I did. So this is Naira. I try to portray Sandra here. And this is Michel. I don't think I did it very well, but okay. It's Bea and Diego and David. Oh, this is Fraser. Fraser was the most difficult one. I couldn't find a way to make Fraser properly. And this is my team. This is me. Of course, this is not nearly me, but it didn't have short hair or white hair, but it was closer. Of course, this is more for young kids to portray themselves. That there is much easier. I have Anna here. She was starting her career here. I have Teresa. Teresa is also not very good. And I have Gustavo, also not very good, but okay, yeah, this is fun. And you can have your kids create their own avatar. And the tool is also available in the website of the project. You also have a list of icons related to careers in space for female and male, also trying to avoid gender bias and avoid stereotypes. Okay, so these are tools that you can use to play with your students and create this nice ideas. Now, I have a question for you, which is the following. Imagine that I enter your houses today, and I say, look, we need some part of your salary to help us fund space exploration. Which, by the way, you are already giving, especially if you are in Europe or in the US, part of your taxes, or in Japan, or wherever you have a space agency, part of your taxes go to fund that. But imagine that I have my private mission, and I go knock at your door, and when I knock at your door, I say, okay, you need to give me 1% or 2% of your salary to do my space exploration. Would you give it to me? And so I'm going to pause it here. And I'm going to open the voting. You have to go to menti.com. And I hope that you can see the number. The number is this one up here. And I'm going to, well, I think you can start voting. Can you please tell me if you can vote? Can you please go there? It's menti.com, and this is the number. Okay, you can vote. Great. Actually, I'm going to hide the results so you don't know what each other is doing. I want at least 30 or 40 votes. Come on, guys, you can do it. Would you vote yes? Would you vote no? Would you give me your money to spending in space exploration? It's okay. Any vote is fair. Yes, no, I don't know. I didn't start my proper conversation to try to convince you to give me money. So if you think no, it's pretty legitimate. If you think yes, also. If you don't know, also. Okay, you have 18 people. Come on, I want more. Some more votes. Come on. 20. A little bit more. Come on. Let me take the timing. I don't see the time now. Okay. 21. People are shy. Come on. Menti.com. And the number is 74 43 97 2. You can do it. Come on. Okay. It seems that it's stuck at 21. Let's see what you guys have voted. Show results. Oh, we have 20 yes. Okay. I have a very good audience here. Well, usually this is not the case, and people tend to vote no, especially if they are kids. If you ask them, would you give me part of your allowance to spend in space exploration? They will say no. And if you have an event where you have the students with their parents, usually parents also tend to say no, because the majority of people, of course, you are already a biased audience, and I expected to have more yeses. But in real life, people don't understand why they should invest money in space. And if you ask them, where do they think the money goes? They don't actually know how to answer. So I usually do this when I go to schools and I do a presentation. And I ask them, what do you think happens to the money that we put it in a spacecraft and we launch it to space and the money is burned in the atmosphere? And so people start thinking, someone trying to say something?
No, sorry, it was me just laughing. Sorry, I mute myself.
Okay. So the thing is that people really don't know. So if you think, okay, no, it goes to the space agencies, and they just burn it all there. So they think what? They make a fire at the European Space Agency and put fire on the money. So this creates jobs. In people that have jobs tend to go to the supermarket and spend their money. They go to the hairdresser, they buy clothes. They have children, they put children to school. It goes to industry. And guess what? People work in industry. It creates jobs. It gets salary. All the money, 100% of the money that is invested in space exploration go back to people, because there is no profit. It's not a profit enterprise. So there is nothing that ends up in Miguel Zorbea or Manuel Castillo bank account. It goes back. Okay, it's only their salaries, which is spent. And usually, space explorers tend to spend all their salaries. There's very limited amount of money that we can save by being scientists and space explorers. So these are things that people don't think of. But there are other side effects of space exploration. And it is how it benefits our life in terms of technological evolution, like anti-scratch lenses or MRI devices or UV protection, digital images, camera sensors, CCD camera. This is all due to space exploration. Usually when kids tell me I wouldn't invest in space, I go to them and say, that's fine. So in your world, space exploration does not exist. That's perfect, no problem. But if you don't mind, you need to give me your mobile phone. You need to give me your backpack. You need to give me your jeans, your sneakers, and maybe your toothbrush and other things that you have in your bag, because in your world, nothing of this exists. So they are surprised with that. When we have parents in the room, they are even more surprised because they never thought about that. It also works, infrared thermometer, lyophilization, cordless equipment, food conservation, fire-resistant clothes, helmets, and I could go on forever talking about the benefits of space exploration in our lives. So after that, you think they are convinced, right? Wrong. Usually they are not. They have to, reflect and think about that by themselves. But we are bringing something to them that they never thought about. Okay? They have to digest the information. But space in our daily lives, or the lack of knowledge in space in our daily life, can also be very dangerous, because it brings misconceptions to teachers, and it shortens our freedom to know where we can go to think beyond. I wonder, when I was in school, I was with Michel. I didn't have internet to go pick up the books or the images that I was analyzing. Even when I started doing my research on black holes, I had to go to the library. I had to pick up books and papers and make copies of them and read them and study them. And there was no function like Control F to find what I wanted. I really had to be very organized in order to have everything that I needed in time. And, looking for features in images, I didn't have Google Earth or, any of, or Salsa J for that matter. I had to do it with a camera that was enhancing the images from the digital from the Sloan Sky Survey. And they were big images that I had to look with a magnifying glass to find the features that I wanted. That wasn't an easy task to do. But when I was in school, everybody believed that there was life on Mars. Even my mother, my teachers, everybody believed on that. And, luckily I had very good education at that time. And I started to wonder why people would say that. I only saw a mountain that happened to have a shape of a face. And about, men going to the moon, or the flat Earth, and that one about the men going to the moon, that's a very fun. Actually, I'm going to spend one extra minute, incurring the risk of spending my time over lunch. But I was invited once to a conference in Brazil where it was about space exploration, and I was going as an educator. And all the people speaking during the conference were sitting in a table. So I saw myself sitting in the same table as cosmonauts, astronauts, and the Brazilian astronaut that is now the Minister of Science, in a very unfortunate Brazil right now. But he's a good guy. But I was sitting in front of the American astronaut, very ignorant me. I didn't know he was an astronaut. So we were talking, and he said, "Okay, so what is it that you do?" I said, "Well, I study black holes." "You had children?" "Yeah, I have 2 daughters, blah, blah." And then I asked him in return, and he said, "Oh, I'm an astronaut for NASA." And I said, "Oh, that's super cool." He said, "I'm Charles Duke." And I go, "Oh, okay." So he said, "Yeah, I walked on the moon." And I said, "Okay, oh my God, I'm sitting in front of a man who walked on the moon. Like, I want to touch you. Can I touch you just a little bit?" And, I asked him about the moon hoax, that people think that astronauts didn't go to the moon. If people ask this often to him. And he said, "Yeah, I get that question often." And I tell people, okay, let's pretend we never did it, okay? And that NASA faked it all. Would they have to fake it 9 times? Because this is the amount of times that we have faked it. And the Russians were, really following close what we were doing, and they wouldn't know that was a fake. So people don't think, people don't have science literacy. And, the more technology we have, the more amazed I am on how ignorant people can be, even when they have information at the point of their fingertips. It's just a distance of a click, and still they choose to be ignorant, and they waste time with things where they shouldn't waste. There's so much to be done that, it's a pity that people waste their time in things like that. Well, these are things that technology is bringing to us. I'm looking at the chat. Let me bring the chat up. Do you know what this image is? Can you tell me yes or not? If this is something that you know what it is? Yes? Can you tell me what it is? Yes, yes. The moon, no, not the moon. Diego, sorry, it's not the moon. Exactly, exactly. This is another probe that just landed in an asteroid. How cool is that? Huh? It was 2 days ago we had a spacecraft landing on an asteroid. And this spacecraft is going to bring back samples of this asteroid for us to analyze. And if you might think, yeah, why should I care about that? Well, of course, again, you are a biased audience. But first of all, seeing what is an asteroid. You know, I see it's rocks, loads of rocks, but these rocks have composition, and there are people planning to explore asteroids for the benefit of Earth, right? I didn't make my mind yet if I agree or not with that. I really don't know yet. But this is actually super cool. Well, in terms of exploring where space benefits our life, I'm going to stop my presentation once again. And I'm spending just a few moments to show you this application from NASA. It's called homeandcity.nasa.gov. All these links are already in the campus and are available to you. And if you click in Explore the City, I hope it doesn't crash. It's loading. And every time it gives you a different information. And okay, here's the city. I'm going to choose to go. No, sorry, I wanted to go home, not the city that I want. Yeah. So I'm going to enter the bathroom of this little house. Excuse me for my intrusion on this privacy. Okay. Oh, there's something here. What is this? Oh, osteoporosis treatment. Space exploration has something to do with that. Interesting. Here. Polished brass finish. Great. What about this one? Bacteriostatic water softeners. Okay. There are more here. Well, let me go out of the toilet and let me go here, the kitchen. Oh, the kitchen has something related to space for me. Okay, good. What is it? Here. Enriched baby food. Okay, that is related to space. What is that? Portable cordless vacuum cleaner. We said that already. Counterport garden. Okay, let me go to the other side. What is this? Water filtration bottle. Ah, I didn't know that came from space. Water purifying. Oh, coffee maker. I can't live without that. Okay, well, let me visit the city and see if in the city there is something that's of interest to me. Okay, air travel. Airport, I hate those. I spend too much time on those. I think the part of COVID that I am actually enjoying is that I don't travel so much. Okay. Direct to advisory system. Okay. What is this? Pilot stress test. Interesting. Inside the airplane? Parachute system, cabin pressure devices, worldwide flight tracking, gear turbine fan engine. Okay, I could go on forever. So you see where I'm going. You can have your students explore this completely and you know, understand what are the benefits of space in our daily life. Okay. How exactly this is connected to education? Well, let's go. So here you have the page of our Space Our Future, where you have you will find lots of interesting resources that you can use for education, and how you can connect this to the curriculum. Okay, and one of the questions that I get very often is, how can I connect space to the curriculum? Well, you can connect to basically anything you want, and one thing that you can do, and these images that I have here, it's not a naive collection of icons. Actually, I should have changed those for the ones from Our Space Our Future, because we have the copyright for those. What I did was I cut this piece of paper And I distributed these two teachers that were participating in a training event with me. And I asked them to tell me a story about space. A story. They just invented a love story about a mission to Mars. They invented the story. And then, okay, sorry, before that, I asked every teacher to write in post-its which were the topics that they had to teach in the next period of the school year. Okay, this is what I did. They wrote everything, they had all the post-its. And then after they did that, I gave them this piece of paper, cut it, and said, guys, together, please create a story about space exploration, a love story. They did create a very nice story about a couple that decided to go to Mars, and then they were trained and how they did train, etc., etc. I added a few more pictures. I allowed them to add a few more pictures. And after the whole love story was created, I told them, now go pick up your post-its, which were prepared before they knew I was going to do this with them, and told them, okay, now you put these post-its in the part of the story where you think you could teach that particular topic of your discipline. And I had history teacher, I had math, biology, physics, arts, and I think I had physical education and music. And they went there and they just put all the contents, they distributed across the story. And so the idea was, okay, so if instead of telling the students, today you're going to have a physics class, or today you're going to have a mathematics class. No, what they could do is, guys, today we're going to learn about space. And all the teachers are working together on the development of their own content, their own topics, but in collaboration with other colleagues. For the students, they don't know if they are learning English or mathematics or drawing or arts or whatever. They don't care about that. They are learning all the content while building on this mystery or this love story related to space. And what we did this in the framework of a project called Stories of Tomorrow, where children had to build a digital book related to a mission to Mars. And all the teachers from the 5th grade in Portugal collaborated and delivered their content by working together on this. And it was an amazing experience. If you don't believe me, challenge me, talk to me, and I'm pretty sure I can convince you that this is possible. Now, we have, and we need for this, of course, a lot of awareness about what are the characteristics of the student that we have, or which kind of tool that we can use. Space awareness is a very good source of information. CSER is another good source of information. ESA education, NASA education. There's plenty of resources, and we've been sharing plenty of them with you. The problem here, and I will be talking about this after lunch, is how do we do it? Okay, and one of the ways to do it properly is by using a methodology that is called design thinking. Design thinking is a methodology where, well, actually, it comes from business. It's a methodology where people are trying to understand how do I make sure that the product that I'm creating is appealing to the audience, the target audience that I have. It's a marketing strategy that is using this, but we are using it in education. We are using design thinking for learning. And I'm presenting to you here a few projects where we are developing this strategy further, okay? It's all about 4 steps that I will talk to you a little bit more about them, that you use to get to know your target audience, being them teachers or the community where you're living, students, or even clients to whom you're trying to sell something. So in the framework of the project called Reflecting for Change, about which I'm going to talk more in the afternoon, and in the project called Global Science Opera for Schools, we are developing further this methodology of design thinking, but not for marketing purpose, or better saying, it is for marketing purposes, but we are not selling a product. We are selling education. We don't get money for that, don't take me wrong. It's selling in the sense that your students are your clients. And if you don't know what is necessary for them to learn, they certainly will not learn, only a few of them. Okay? So the way to do this is the following. First of all, you need to know your students. You need to know who they are, where they're coming from. We're going to talk again about this in the afternoon. You need to understand what kind of learners they are. You need to know if they are abused children, if they are hungry, if they are sleepy, if they have any preferences in terms of how they learn, if they have any favorite subject, if you are reaching out to them, if you're communicating with them, if they prefer stand up when they are working, if they prefer listen to music. You need to know the characteristics of your students. Otherwise, they won't learn as well as they could. So you ask me, yeah, as if I had time to do this all year long. Well, you only have to do it once. Promote a party, prepare a game. And actually, this is something that we are working on right now. And this package will be available to you on how to do this with a simple game. Find out what are the main characteristics of the students you have. And this is a very important. Well, after you know your students, you know who they are, and you imagine a solution for them. And this is an example of classrooms that were created. These examples, I didn't invent them. I visited two of them. This one here is a class in Bilbao, in a school in Gijón, where the parents brought things to home. So the school didn't have to spend any money on it. And they just refurbished the room where the kids learn English. So they are working with headphones and learning English autonomously in collaboration, developing projects, but they feel at home. It's just a continuation of their homes. We already talked about this on Monday. This is another one where the teacher decided to go to the ice cream shop where all his students were, they're really so happy in the ice cream shop. And he said, I don't recognize my students in classroom. They are nothing like this, nothing at all like this. So the teacher decided to ask the owner of the ice cream shop to help him mimic the ice cream shop in the classroom. And the guy helped him, and this is the result. This is in Madeira Island. This teacher, Ana Lucia, decided to bring the students to the garden. And they created these tables and places where they can sit, and they are having classes, physics classes, whatever other class outside. So she reimagined the classroom setting so that she could reach out to the students. The other thing is, let the students take the stage and help you find the best solution for them. So you have to create a solution that suits the student. And usually what we do is, okay, I create a challenge for the student to go through the cycle of design thinking themselves and understand how they're going to solve a problem that you put for them. Like, for instance, taking the images that Manuel shared with you, and there are fires in your location. For instance, like in Portugal, we have lots of fires. Well, let the children think about it themselves. They will feel the problem. They will get to know the problem better. They will use Google Earth to understand, oh, the area where I live used to be much greener. What happened? Fires, why did it happen? They will find what the problem is. They will imagine a solution. They will try to create a solution for it. And after they have done their work, or after you created a solution for your students, you will then share with the rest of the community. This is the design thinking model. Feel, imagine, create, and share. This is the design thinking model for working with your students, okay? It's a lot of work. Yes, I told you in the very beginning, being a teacher is a lot of work. There is no way around. If you don't like to work, stop being a teacher. Teaching, training is a lot of work, okay? But it's so much satisfaction when you see your work coming true. We just produced a report for a project called iDiverse, that was coordinated by Núcleo. And the results were amazing. And I'm just showing you one example of the things that we did through that event, that project. So we train the teachers, which you always do. We not only train them, we also support them. And then we engage the whole community, the whole school. We have the teachers think about if the school is open to the community or not, which is something that we are also developing in Reflecting for Change. Is the school working properly with the community? Is the community being addressed and the problems that the community have being attended to? The second, so there is a reflection tool, a self-reflection tool that helps the schools develop a plan to improve the way the school is handling not only digital tools, but also the way they are working with the communities, okay? And after that is done, then the teachers can involve the student and start thinking about creating the solution, okay? When involving the students, we use a methodology called personal geography that was introduced to us by a colleague in Greece, Eleftheria Sorlidaki from Elino Germanica Gogi, where you understand what the students know about a certain topic, and you can evaluate how they progress while they are learning. Then several projects came out. Students adopted the projects and they learned. The teachers are training the students exactly as we train them on how to use the project and how to perform the activity, how to fill the community, how to implement the project, how to imagine solutions. These are real students that have imagined solutions for their communities. Created solutions in this particular case is to save bees from extinction, because if bees die, we all die too. They created the solution, and after they created it, they shared it with the local community, with the media, and we have here, they created what we call a science trail, and the teachers were even in the TV, in the local TV, sharing in the main news channel what they have done in the framework of the project, okay? So we do need science literate individuals capable of thinking by themselves and understanding their place in the cosmos, which is something that we are not doing. So I will end this presentation with a series of slides that I prepared for a TED Talk that I was invited to in Patras. And the topic of the TED Talk was a TEDx Patras, was uncertainty. And I thought, okay, this is what our life is. It's about uncertainty. And people do know that, but not really. They don't really understand it. So I created this uncertainty in astronomy, or it could be exploration. And I start with this very old image that we don't really know who the author is, where, you know, you have a man, when this is at the time that people thought that the Earth was at the center of the universe. Well, we know now that the Earth is not at the center of the universe, but we can easily say, okay, what about the universe? What is our universe? Is it the only one? Are we at the center of anything? In our universe, we know we are not. There is no center in our universe. But what is the rest? Is there a rest? We don't know. So we are more or less in the same position today. We can ask, for instance, things like, what is time? Does time really exist? Have you ever thought about that? Do you believe that time is something real? How do we track time? We track time because we have the orbit of the Earth around the Sun. We have the Sun orbiting the center of our galaxy. We have the movement of our galaxy. But what if nothing of that existed? How would you track time? Does it really exist? Does it really pass? Are you sure about that? What is it? Because you're older? You're getting older? No. Have you ever thought really about that? Or about, we can talk about the constants of nature. If they weren't exactly fine-tuned as they were, if they didn't have the exact amount of the value that they had, we wouldn't be here. Why is it? Is the universe like this for us to be here, or we are here because the universe is as it is? Are there other universes where the constants are different and maybe life is completely different? Could this be an image of, you know, could we be inside of such a little bubble and other bubbles exist? We don't know that. Are we alone in the universe? Is there more life in the universe? We don't know that. We think and we hope we are not. Scientists believe that there's so much life out there, but we are not sure because we never discovered yet life outside of the universe. I showed you this at the beginning of the week, you know, how small our planet is inside the solar system. This is a picture taken from the solar system near Saturn, and we don't see, well, we barely can see Earth down here, right? And we don't see each other here. We don't see us here. finding life in the universe is pretty damn hard. Okay, and we haven't found it yet because it is hard, because the universe is gigantic. We can consider things like, what if the moon didn't exist? Maybe the axis of the Earth wouldn't be so stable and we wouldn't be here. Life wouldn't have emerged on Earth yet. What if Jupiter was closer to the sun than it is right now? Would we be here? Perhaps the gravitational perturbations that Jupiter would cause would avoid us, would prevent us from being here. What if the sun was a red dwarf? We would not see in the optical as we do. Would we perceive life in a different way? So what if the sun had a multiple star system, was part of a multiple star system? Again, the perturbations might prevent us from emerging as a civilization. Well, there's a lot that we don't know, but we do know a lot of things. We have a very good theory on how the first atoms and molecules and stars and galaxies and life emerged. We do know that much. There is so much that we still don't know, right? We know from Einstein, for instance, that time does not behave exactly as we think it does. You know, we have the twin paradox. Like if you have one of us sitting on Earth, actually this experiment was done, I don't know the results yet. If you take twins and you put one of them in a spacecraft, and that spacecraft travels to space in a very big speed and comes back, the twin that remained on Earth is older than the one that traveled. And we have proof that this is like this by testing muons, for instance. Time dilation is also an intrinsic part of GPS. GPS wouldn't work if we wouldn't take this into consideration, and so other things. So time and space is not like we perceive it in our daily lives. It's much different out there when gravity is strong, for instance, where speeds are high. And if we don't take this into consideration, physics doesn't work, and we know that for a fact, right? But 99.9% of people in the planet don't know that, right? They are worried about the football match from yesterday. They are worried about if the moon went to the moon if the man went to the moon or not. They are worried about small and ridiculous things sometimes. Well, I'm not saying that football matches are small, although I don't like them, because, you know, opening a newspaper with a football match, so many is going on in the planet, really pisses me off. So there's uncertainty everywhere we go. What we see here is it's a mirage of a series of one galaxy behind this image here. So all you see here is a mirage of a galaxy that we don't see. This is not real. You know, we see that in the picture, but it really doesn't exist. So more than that, when we look to the universe, we only see the past. We don't ever see the present, not even in our daily life. You want to know more about that? You have to talk to me about that, so I can tell you more about this. Gravitational waves. We learned a lot about gravitational waves this week, but there's so much to be learned. It's a completely new library that we have discovered, a new way to communicate with the universe. We're going to discover so much about the universe because we discovered gravitational waves. So there's lots to learn. We are discovering more and more about black holes, the Nobel Prize winners of this year. This is the first ever image of a shadow of a black hole. We still don't have the fire burning proof that black holes exist, that things can actually enter, that there is what we call an event horizon. Much is yet to be discovered. But we do know for sure that we exist. We know for sure that the universe is filled with galaxies. We know for sure that there's lots of gas and dust surrounding us that we can see. We know there are stars, there are billions of them. We know that for a fact. We know there are planets out there. We have discovered thousands of them outside our solar system. We know there is one planet that harbors life. It's our beautiful planet, right? We know we have learned a lot about our planet. We have sent out spacecraft out there. We have astronauts exploring space and telling us every single day lots of new things about our universe. We know that we live in the habitable zone of our planet, of our solar system, and we know that our solar system is in the habitable zone of our galaxy. We know that our galaxy is part of what we call a local group, a very tiny group of galaxies, and that the local group is just one tiny part of what we call the Virgo cluster, a cluster of galaxies, that is just part of what we call the observable universe. Okay, so this is all gigantic, and 99.9% of humans don't know that. This is one of the most spectacular images taken in the last century, is the Hubble Space Telescope Deep Field. Each and every single dot is a galaxy in a picture that was taken really out of a little spot in our sky, right? So, okay, I'm not showing the video. There is a very nice video that I will give you the link to that. And, you know, people still don't understand that it's just one single, very small world filled of people like us, and that color, race, social, religion, beliefs make no difference. We're just all alike, just people. You know, no countries, no border. That doesn't make any sense at all. It's just one sky for us all. And I do hope that this week gives you enough inspiration to value this magical place, and make sure that you make a difference in each and every student that you have, because if you are leaving one of them behind, they might be the future Hitlers or Trumps of this planet. So make sure you value every single life that is put to your hand. You can make a huge difference to each and every one of them. So I guess my time is almost up. I will stop here and I will stop sharing my... no, I'm not stopping. I'm not ending it. If you go to the campus now, you will find a new tab. It's called Our Space, Our Future Kit. And as I promised to you, you will find here all the goodies from the project. You'll find the project page and the social media. If you click here, you find the website to create, to have your students create their own avatars that they can share in any social media they want. You find the animated GIFs that you can copy and use it freely, please. You find the coloring sheets. Actually, I have them all here. I can show they have this black background. And yesterday I asked for the creation because one of members of my team, Priscilla, suggested me, why don't you have them in a white color? So you have them to share with your students this very nice coloring sheet. You have all the icons that I have shared with you. You have to click here to have access to the original versions. You have the career icons also ready for you. It's a very nice package that the team of Our Space, Our Future have prepared for you. You have the link to careers, to space awareness, to NASA Home and City. And I really thank you on behalf of Our Space and Our Future team and Nuclear team for paying attention to my presentation. And I stop sharing. They have not paying attention to the chat. I'm going to open it now to see what did I miss. Okay, are there questions for me? Thank you, Alex. Okay, Diego is sharing a memory. I cannot go up. Okay, there are no questions. Clear and good presentation. I don't know, Michael, are you around?
Yes, I'm always there.
You're always there. So maybe we can free them for lunch a little bit earlier then?
Yes, I would say so. Let's have lunch, and we are back in at 14:30 Central European Summer Time, which is 12:30 Universal Time.
Okay.
See you then.
Thanks, everyone. See you later. David, put out a good dish of food to get us hungry.
I go. Some tapas.
Okay, wait for me there. I'm coming.
Very nice. Very nice. So hello, welcome back. I hope you had a good lunch.
Michael, maybe it's just the two of us here. Everybody left.
No, I don't think so. We have
You don't
47
think
people
so?
connected.
Ah, okay. I thought I could have just a cup of tea with you.
I have Sandra. We have
I'm also
Sandra.
here.
Sandra, you're also
Hi.
here, Sandra. Okay.
So very good. David is also here. We have 48 people. Yeah, so let's get into more own stuff, no? Digital skills.
What's
We
it?
have to warm up first. I always
The
forget
warm
to
up first.
Yeah, we
You
should look
always
at the warm
forget
up
about
first.
that. Yeah, you were the first one in need of it because you were totally asleep, you know. Oh well, I am just turning on Google Earth. I just click on it. Let me share my screen. Let's see how well our team did. Okay, first of all, I have to figure out. Okay. Okay, I guess you can see my screen
Yes,
and you see.
yes.
Okay. So today is the day for finding the favorite places on Earth, right?
Yes.
This one was the one that I talked yesterday. It's actually yesterday I talked about another place in Principe Island that was near a place called Belmonte. But today I show you Roça Sundi. Who knows what Roça Sundi was? Anybody in the audience knows? Let me turn on the chat. Why Roça Sundi is a global important place? You have to say yes before you Google it. So I know you know why this is important. No one? No one knows what Roça Sundi was? Come on, guys. Okay, I will show you the beautiful picture of the place that actually now is, this is not the image I saw yesterday. Wait, let me see if I do like this. Also not the view I had yesterday. Okay, I have to Google Earth more. Don't want just the picture, I want the view. Okay, well, now this place was transformed into a hotel. A very nice one, by the way. No, click here again. You think it's going to go there? No, it's just going to turn around. That's not exactly what I wanted, but okay, that's fine. Okay, so now I want it to turn again, and I don't know how to turn it. How to turn this around? Anyone knows how to turn this around? Do I turn this? How do I turn this around? Okay. Well, this is good enough. Okay, so Roça Sundi is the place where Sir Arthur Eddington made the first observations of a solar eclipse that helped prove Albert Einstein's theory of relativity to be right. And he did these observations. You can imagine that even nowadays, it's not easy to get there. Now they have made roads, but up to, I would say 3 or 4 years ago, in order to go for, I don't know, 1 kilometer, it will take you like 10 to 20 minutes because it's just earth, and it was difficult to get there. But now they have transformed it into a hotel, and the person who designed it did a good job because he preserved all the lines of the initial home that hosted Sir Arthur Eddington there with his expedition to this small island. And it was, I think, let me see if I know things properly. So now my geography is not very good, but if we enter here, no, that can be it. Yeah, exactly. The main house is here. So it's somewhere around here, exactly where I have my mouse, that Eddington put his telescope and observed the solar eclipse. That helped put Einstein into the mouth of everyone here and in another place called Sobral. Okay, who else has something that they want to share? So project, let me click on projects. Is a GTDP journey. Sandra, do you have your pin here?
No, Rosa, sorry. I didn't put a pin. I'm so sorry.
Shame on you, shame on you.
I should have put the Canary Islands, I think I would have chosen.
Okay, anyone has their pin there? Can anyone tell me? Okay, we do have participants here, right? How many participants? Let me turn it on. I don't have the participants on.
52.
52. Nobody's saying anything. So I know that Michal did it. Okay, so we have we do have a few people. Okay. Oh, okay. Oh, let's go slowly. Marina Mola has shared. Let's see. Favorite place on Earth. This is what we're talking about. Marina, is this one?
No, I am in Greece, Komotini, Greece, Marina Mola, 9th primary school.
Yeah, I know. But you put a new pin because I already have shown you. Is this a new pin?
Pin.
Okay, no. I asked you all to put a new pin with your favorite place on Earth, okay? So let's see.
Okay, I will do this.
Okay.
Yes, no, I shared a picture with the sea and the hobby that I have. But I will put one. I would add my pin.
Okay. So
can we not see the picture, the image?
Well, now I'm moving to the next one here. We'll come back to you, okay? So we have this. I just discovered that I can see in the order. So after me, we only had 3 pins, and 2 are from the same person, Casa Leni. So I have no idea whose pin is this one. Let me zoom out to see where we are in the world here. I still don't know where I am. Casa Leni. I guess we are in Mozambique. Nice. Very nice. Okay. A place to visit.
Rosa, some people are asking for the link again in the chat. I don't know, maybe we can share it again.
The link is here. Here. So then we have Marina from Azores, Angra do Heroísmo, which is something that I have shared also, the volcano there. Nice, Marina. Thank you for this. And nothing else. Okay, so I'll give you a few minutes. We still have a few minutes here. Okay, I see people writing, but the thing is that I put Sundi yesterday and Del Monte, and only these 3 pins appeared after that. So I'm hoping that some more pins are going to appear now. You're not very good with your homework assignments. Let me see if we are successful here. Is anyone putting a pin? Diego said he's going to put a pin in Benidorm. Okay. Oh, Errol says that was Tofo Village in Mozambique where he scuba dive. He does scuba dive. That's awesome. That is certainly an awesome experience, Errol. Thank you for sharing that. You guys, you have to give me just a second. I'll be back in a moment. I'm back. Sorry for this. Okay. Let's see who else is going to put a pin here. Oh, I don't see a pin in Medas. Let me go back to Europe. We have here in Tabarca, the European Space Agency. We have Bilbao. We have Leon. Leon. Medas. Medas is here. Yes, it is. Click here. No, this was Lamego. Okay. This one, Medas. It's a Portuguese locality. 2,000 inhabitants. Very nice. Seems like a very nice place to visit. So you are all invited to go there. And visit Natividad. Okay. We have Philippines here. Yeah, I noticed we have. In the US, let me see. I have not been to the pins in the US. Let me turn this off. Sorry about this. Okay. So let's go slowly, make the trip so you guys don't get dizzy. And do we have US here? We do. We have one. Is this one? Las Cruces. Let's check. City in New Mexico. Okay, let's click on it. It's coming or not. That first image seems not to be added. Oh, that's very nice. That's a very nice place as well. Look at those mountains. So much geology to teach here. Very nice. Very, very, very nice. Okay. Well, again, you still have time until the end of the afternoon to put more pins. Let's see when we circumnavigate the globe. A little bit more zoomed in. We do have a few people from South America. Very few, although I do know that we have lots of people from there, also from Africa, which are not here. And I'm going to show you actually, this is the back office where we have been creating all the campus. And from the back office, if that, oh, no, this is not what I wanted to do. This is from that platform that I told you called Grasp. Let me go to my home page, and I will show you the map on where in the world the participants of this training courses are coming from. My computer is a little bit low. Okay. Okay, and I can show you this map. Look, these are more or less the activities that we have from all over the world. So this is Europe and North of Africa. We have South of Africa. This, I bet, is Sarah about sea activities. I don't know. We don't have this information. We don't have access to who it was. More or less, just a region, more or less. We have South America, look, many people participating. We have North America here, very good. We have, look, Southern Africa, we have India, Pakistan. We have also all this region of the Pacific Rim, very nice. We even have people from Australia, huh? This is pretty cool. Okay, so let us start for now. This is going to be a two-part presentation. I will start with my part, and then Sandra is taking over the floor. Again, okay, let me put this in presentation mode. I don't overwhelm you with the amount of information, but I only have you for a few days with us. So I really hope that I can share the best I can. Again, these presentations are going to be available to you for you to investigate everything. So we are involved in several projects. Some of them I'm bringing here to you. And this presentation is based in the work of projects that I have already shared with you, but I'm going to share again. One of them is the Reflecting for Change. The other one is just starting, is brand new, is the OpenTeach, and the third one is InSteam. So Reflecting for Change is working with schools, and by that matter, if there are Portuguese schools here that want to participate actively in the project, please let me know, contact me. We are just accepting registrations for the project here in Portugal. And what the project is doing is, and of course, I think I will be able to open the opportunity to other schools around the globe. It's just that the full support that we are offering for Reflecting for Change, we cannot give to all the schools at the same time. We can give to all the schools, but not at that specific time. We can take 100 to 200 schools at a specific time. So the idea of Reflecting for Change is to make a survey, to have schools fill in a survey where they will have an X-ray of the school in terms of which are the digital skills, the competence profile of everyone in terms of digital tools, and how the digital tools are being used to improve learning, to promote team building, to promote communication with the community, to showcase what the school is doing to the world outside. So this is the purpose of this tool. So once the school has this X-ray, the school, with or without our support, can prepare a development plan and to try and target the problems and issues that they have discovered through taking this self-reflection tool. And after that, after the development plan is done, and usually schools use our support to do that, we suggest a series of training courses that the teachers can take, or the staff, or the headmasters, in order to be able to change the way the school is working as an organism, as a living organism, within the walls and outside the walls of the school. And usually there's a lot to be changed, and usually people have no idea that they have the problems that are depicted when they take this self-reflection questionnaire, this survey. So this project is about, helping schools reflect and develop a plan to solve the problems that they might encounter for the daily work of the school as an overall. The OpenTeach is working specifically in the aspect of the digital competence profile of teachers, because usually teachers are using just basic stuff. They are using PowerPoint, they are using YouTube videos, and Word, Excel, and that is it. And there's so much more there that teachers don't know, and they are not using it. I mean, having a computer and a projector, or what's the name of those interactive boards, this it doesn't mean, the fact that the school has it doesn't mean that it's properly used if you're using PowerPoint or just Word or Excel without a full overview of what you're doing. Okay? The second part of this, the combination of these two is the open schooling approach, which means is your school the hub, the heart of the community where it's embedded in, or it just happened to be a school in that locality? Is the school serving the needs of the locality? Does the school knows what are the needs of the needs and also the opportunities? The school knows which are the, for instance, the professions that are there sitting around the school and that maybe can help enhance, improve, and enrich the experience of the students while they are learning in school. Do they invite parents and other experts to the school? Is the school supporting those in need in terms of knowledge? Where do people go when they have a question about should I vaccinate children or not? Should I wear a mask or not? Where do they go? School can be a hub for them. Okay, and this presentation is also about inclusion. And there is a project called InSTEAM where we are developing a series of activities devoted to climate change, renewable energy, and other topics. But we are trying to use the inclusiveness in the lessons. And I will explain to you in a moment what I mean with this inclusion. So I will show you a few things that I'm sure you've never seen, or some of you have never seen. And I'll try to explain to you why they are important. I just bumped into those things when I'm doing research for my presentations and for the projects that we're participating in to make sure that we are up to date to the several reports and information that the OECD, UNESCO, or the World Bank, or all these big institutions are providing to us. So one of the things that I found was this digital intelligence coefficient. So instead of measuring the IQ of the students, how about you measure the digital intelligence of your students? Do they know how to use digital tools? Do they know how to prevent a bad marking their digital identity? Are people aware of their digital rights? Are people creating enough literacy about what it means to have digital things? Do people know how to communicate using digital tools? And other important thing, how do you show empathy? How will you communicate emotions if you're doing things digitally? How you make sure that your data, your information is secure, is safe? Do you know how to use things? So for a student to be prepared, a student needs to learn how to be a digital citizen. And for that, they need to know how to make sure that that information is safe and that they are using technology in a responsible format. They need to be able to transform their ideas into reality, making use of the multiple tools that are available right now out there. And they will need to thrive in a world that is highly competitive in terms of digital use. It will be necessary for them to know how to handle data, how to develop entrepreneurship skills, how to make sure that they have an impact. So all of this is part of what they have to learn in school. Yes, this is what schools are all about, preparing students for that. This is the main goal, okay? So the European Commission have developed a digital competence profile. Actually, there is a new digital action plan, but there is a digital competence profile for educators and learners. And they have developed this tool called Selfie, which is part of Reflecting for Change. So in Reflecting for Change, we have embedded all the questions from Selfie, plus all the questions related to know if your school is an open school or not. So this picture here is just a framework that was created, which I think is a brilliant competence profile. It's the Digicomp framework. I see that the title is down here. I apologize for this. I will bring it up and make it visible to you when I put the PowerPoint online. And all of this is investing in the most important capital that a community must have, which is, or a person, if you want to see that way, is the science capital. Is the knowledge that is there, what you know. The science capital is how you think, what you think, and who you know. This is what forms the science capital. And you can measure the wealth of a community by the science capital of each individual, okay? And this is something to be taken into account. When the schools are preparing their self-development plan, they have support from projects like Open Schools for Open Societies, which we had the possibility and privilege to be partners with, where there is a roadmap is designed, and for Reflecting for Change, there will be the same, but now enriched with the combination of the open schooling and the selfie approach. So digital tools and community combined together to help headmasters and parents associations and teachers and everybody to develop a plan that makes sense for their community, and not a plan, because copying a plan for the neighboring school doesn't make any sense at all, because it's not tailored to the specific needs of my school. I can be inspired by what the other school have done and try to apply to my school, but I do need to know what is necessary. And this part of the self-reflection tool will analyze the management level of the school, the process level, and the professional development. All of these are things that are very important to understand where the school is embedded on, how the school is organizing itself, how the school works as a company, because this is what a school is. It's a group of professionals trying to develop a product that serves the community they are embedded in, serve the purpose of the students, that fulfill their needs. So the problem and the question that comes into mind here is, how can you teachers do it, right? How can you make sure that this is possible, that this can be done? So there is this saying that says, it takes a village to raise a child. And you do need your headmasters, you do need your colleagues, you need the community as an overall. Without that, you cannot go far. Okay? Is it easy? Is that easy task? No, not at all. And I know that many of you are solitary runners, but we can do, a lot to help you, at least to help you identify what the problems are. And maybe with the support of your students and their families, you can change the reality of your schools, because your colleagues are not bad people. They are just not feeling they're part of the solution or part of the problem. I'll go there in a moment. And I had a colleague the other day that said, and very wisely so, that sometimes it takes a child to raise a village. And maybe this is the case for many of you. So here I'm taking something that I steal from the OECD for a Better Life initiative. And this is basically what the schools are for. The schools are there to prepare the students for the world of work, for their future life, to give them jobs so they can have an income and they can have a house. They can have a work and life balance, that they know their safety, that they are satisfied with their life, they are healthy, they know their civic engagement, they care for the environment, they are educated, and they care for the community. So students can start working on that right now, today, by looking at the community, by looking, what are the problems? Do members of the community have the appropriate jobs? Do they have the necessary income? Housing is something that is a constant in the community, so on and so forth. So the school has a responsibility towards it. The school shouldn't be a building with walls surrounding it, preventing the community that it serves from coming into the school. Because there are problems. If there are problems, they need to be solved. And nothing better than an active school to help solve the problems by its root. And the way to do it is through education. Okay. So what are the roles of the schools when we face global challenges and when we try to find local solutions? And how do we do it? Well, the secret is in what we saw already, is in design thinking, in empowering students to do precisely this. Go out in the community and feel what are the problems that they would like to solve, and feel the origin of the problems. Is the problem that arousing their because they come from a migrant community. The community came from somewhere else. They are completely dislodged. And the problem is that they don't feel part of the community. So this is the problem. And instead of trying to reinvent the wheel, or instead of trying to impose a solution that you think is a good solution, engage, empower the students to be themselves together with you, with your guidance, and maybe with input from the community to imagine a solution that will mitigate some of the problems that they find. And then together create a solution or a trial for a solution. It can be just a minor problem. It can be trash, can be lack of places to wash up, maybe a lack of bread to everyone, maybe a minor problem. But you will be amazed on how creative children are to find solutions to some problems that we think they're there forever. You know, you will be really mind-boggled to see how kids are creative, and they are not biased because they often their brains are not completely formatted against good and brave solutions. And then let them create it and then share the results, good or bad. A bad result is also science. It didn't work, it failed miserably. It's a great result. So we know that is not the path to go. We need to go to the other path. And by that matter, something that I think I never told you during this week, making mistakes is the best thing a human can do, because that means you are learning. So make sure that when your students are making mistakes, you're not pounding on their heads or say, oh, come on, you're doing such a silly mistake. Just, you know, empower them and say, making mistakes is good. You are learning, and this is good. You know, not so that they don't grow up afraid of making mistakes. So when it comes to your students, it's not just that you learn about themselves, as we saw through the design thinking, in terms of, okay, where do you live? Where do you come from? Or you like music, or you like dancing, or you like reading. It's important that you also understand what is their learning style. Are they visual people? I'm a visual person, as you can see from my slides. If you give me a block of text without any illustration, I have a very hard time understanding what I'm reading. And I don't consider myself dummy, but I do have a hard time if I have to. Okay, I love reading books. I read books a lot, and I love that, and I don't need illustration to read books. But when it comes of learning things that are outside of my comfort zone, I'm a visual person. There can be kids that are auditory, they prefer listening to things. They learn more if they listen to it. There can be people that prefer reading. They are more shy or interpersonal. They prefer writing and reading. There can be kids that they only learn when they are moving. So you need to understand what's the style of these kids. And this is something that we are developing right now, a kit to address these specific things. But we're not inventing this. This already exists, and there are tools out there. I didn't appreciate any of those, to be honest, so we're trying to create something new, but it exists already. There are tools that help you identify the learning style of your students. You need to identify their personal characteristics and skills. You know, are they creative? Are they curious? Do they have hope? Are they optimist or pessimist? Are they resilient? Are they tolerant? Do they tend to be to have a vision for the future? And if they don't, they lack some of these skills. If they lack some of these characteristics, then you can help them improve the specific characteristics. The culture and social background, where do they come from? What are their values, their attitude, their prejudice? What are the specific needs? Do they have any kind of disability? What is their perception of the world? How is their family working? Do they support the students? Do they not? Do they have a community of support behind them? All of this needs to be taken into account when you are making an X-ray of the students. And you only have to do this once. And you can do in a fun afternoon, in the format of a game, so that you understand who you are dealing with, who are the kids and their families. Without knowing that, you will be caught by surprise without understanding the results that you are getting. So, if anyone needs to ask a question? No. Okay, so can I ask you to please make sure that you have your microphones mute so I know if someone is willing to ask a question? Thank you. So there are always ways to have inclusive things, but These are pictures of some inclusive astronomy events that we did with some of colleagues of ours and some partners in the globe. EU has a very strong inclusiveness astronomy department commission, and they are doing outstanding work. But inclusion is not only that. Inclusion is also about gender. It's about diversity. It's about tolerance. It's about solidarity. It's about equity. It's about equality. And you know, when I prepared this slide the first time, I actually am going to minimize this now. And oh, sorry, I wanted to be able to see this picture. Okay. Can you tell me what's okay? Can you see this image? Can you please tell me if you see this image? I want you to look at this image and tell me what you think about it. Can you write it on the chat? What do you think about it? I'll put the chat here so I can read it. Do you like this image? I adored it the first time. This first one to the left. I adored this one at the first moment because I thought, oh, this is telling, okay, different skills put together will give out a great product. This is perfect. It's really, really awesome. But I will increase it a little bit more. They're having fun. They are learning. Yeah, indeed. This image, but there's something very wrong with this image. Can you tell me what it is? What is wrong with this picture? I don't see your faces, so when I do design thinking, I also became very good in reading non-verbals and seeing face expressions, and I miss this here. No, they are sharing. Everyone is sharing their knowledge with each other. They are building a perfect collaboration, a perfect cooperation here. But there is something that is wrong. Very, very wrong. They are working together for something, but there is something very wrong. I will increase it even more. I hope you can see better now. Only boys. That's correct. This is only white men. So this is giving the wrong impression. If I am a child and I see this picture, I think immediately if I'm a little girl, this is for men. It's not for me. If I am a Chinese or an African girl, I look at this and see, this is not for me. It's implicit bias, and we have to avoid this. And there's so much of this everywhere. I couldn't find the image that was perfect, and I apologize for not having a perfect one. This one is a little bit better because you can see different hands, that's a younger person, and a little bit of different colors. But I didn't find the one that I really preferred here, okay? But that's it, you know, when we have these little stories for children, how often do you see, like the rabbit, you know, the rabbit, the father takes the suitcase and goes out working, and the mother stays at home and cooks and cleans and take care of the children. Nothing wrong with that, but that's only the thing we see. The female stays at home and take care of the children, and this is her place. I've been told once that this should be the place for me instead of doing science. So this is not okay. This is not okay. Everything should be run on the base of equity. And, you know, when we talk about equity, let me put this in presentation mode again. Equity is not about, come on, go back. It's not about giving the equal opportunities to everyone. It's giving the opportunity that the person needs. Some people need more help to get to the same stage than the others. And this is something that you have to take care when you're looking to your students. You need to make sure that you understood what are their needs. Otherwise, they're not going to get there. Okay. Well, for that, you can use the universal design for learning principles. Actually, I should have written here universal design for learning. Universal design for learning is not invented by us. It's on the web. Just search for it. It's a very a methodology that is there for a long time that helps educators create their create their lessons in order to be adaptable to everyone, regardless their learning style, regardless their social and cultural background, regarding the skills that they have and what they need to learn. So how do we do it? And I found this example, and it was really very nice. You can either make a buffet. You know, when you go to a restaurant, I tend to be vegetarian. Imagine what happens to me if I go to a restaurant where there's only red meat. I can't eat. I can't possibly eat. That restaurant didn't use the universal design for learning. But there are restaurants that have this meat, but they also have a salad buffet, which I love. So I go with people to restaurants where they serve meat, and I have the greatest time if they have this super buffet as the ones that I go. So this is universal design for learning. I design things so that they can be good for everyone. Okay, so there are several stories on YouTube, if you click on universal design for learning, that will help you reflect on that. Am I being inclusive? If you're not using the universal design for learning, you are not being inclusive enough. So you have to accommodate, you have to give the students multiple means of representation. Or, in other words, you have to show information in different ways. You have to give them multiple means of action and expression. So give them the freedom to approach the task at hand in different ways and demonstrate their learning in different ways. And you have to tell them why. Why do you need to learn this? So give them multiple means of engagement. If you don't engage the students, they won't care and they will not want to learn. Okay. So if you want to know more about how to build a good inquiry-based learning activity, go visit this page. Again, I'll give you this PowerPoint and you will have this link there. And there you have some interesting tips on how to design a good inquiry learning scenario. You have a full tutorial in the support page that help you in there. If you need help for that, let us know. And we are intending to have courses on that. And for people in Portugal, we do have accredited courses for GoLab. This is one example of an activity that my team created, which is how do you create a gender-friendly ILS? How do you ensure that your lesson is not introducing students to a gender bias? Again, I will make these links available to all of you. So I know that it's not easy because, you know, even if you feel inspired, you might not have the proper atmosphere at school. You might not have funding, which, by the way, you don't need to introduce real changes. You don't need funding. You might think your colleagues will never go for it. And you might have problems with your students that are not interested and not inspired, and you don't know how to handle them. And what I have to say to you is the following. You need to do marketing. You need to find a way to create enthusiasm to your colleagues. You need to create a team, and there are several team building activities that you can do that will break the ice between you and your colleagues. Sometimes they are not bad people. They are not giving you a hard time just because they don't like you or your voice or your color. It's just because they don't feel comfortable and they don't feel engaged. The same goes for the community. The community is not supporting you because they don't understand why they need to support you. So if you're asking for something that people don't understand why you need it, they won't help you. This is the same thing as a company willing to sell something to you. They will not sell if you don't understand that what they are selling is important and good for you. This is marketing, people, pure marketing strategy. If you want to know how to create a good community in your school, marketing strategy. If you want to know how to engage your students in community, marketing is the key. And the way to do this is something that also my team have been creating for a while, is the 5 pillars of community building. And this works for your students, for your colleagues, for the community, for the staff, for everything. The first and most important pillar is you engage. You make people feel this is my project too. If it's your project and they're going to help you in your project, chances are that you will fail. If you create a project together with your colleagues, so that is a joint project, then it's their project as well, and you are engaging them. The second part is find out what kind of training you need. Okay, if you are not being trained properly, if you are training people on how to use a certain methodology, when in fact what they are lacking is digital skills, you're wasting their time, you're wasting your time. So train people to fulfill the needs that they have. And after that, provide support, because training alone is not good enough. You are going out of this week full of ideas and inspiration, and on Monday, you will go like, oh, well, I don't even remember which was the first software that I saw. Where do I click? Where do I find it? What was exactly the address that I had to go? And if you don't have us, if you don't have our email to knock at our doors and say, I need help, then you probably will not use most of the things that you have learned. But if you have someone to support you, maybe in the WhatsApp group, you will find someone that will help you, a teacher that say, oh, I've been there too. Why don't you use this link? Why don't you use this tool? This is the support that we can give to you. It's put you in touch with other people. Give certification, accreditation, recognition for the work that people are doing. Recognize the effort of those that are helping you. No, this is truly, truly something that is very important. And engage many stakeholders, everybody that you can in the effort that you are building. So chances are that you will try. So this is what we do. We train teachers in events like this one that we are having now. We have this European School Innovation Academy where we provide many opportunities on several different topics. We are partners with them. And we are every year announcing several courses. Those of you that are in my mailing list receive this, and you can participate. This year, you could participate online from wherever you are, like you're doing now. And I think that we will keep these online courses going on forever. So there is always going to be an opportunity, not all of them, but some opportunities for all of you to participate in this training and the continuous support. There's also several projects that you can take a look at. I will provide the link to you for those projects that you can find as inspiration to work with your community. These are projects that have been following the inquiry-based methodology, the feel, imagine, create, and share. And there are descriptions of several projects that you can do with your students, or simply inspire yourself for projects that you can maybe take on board. One of these projects, for instance, was one project about light pollution, where we had a small boy, a 7-year-old, that convinced the municipality to change the illumination of a big municipality here in Portugal to prevent the problems with light pollution, which is a whole new topic that you can learn to if you participate in all the training events that we promote. And I'm almost handing it over to Sandra, just telling you that as many of you here are not from Europe, and I always receive, because my mailing list is general and I send it out to every people all over the world, and many times the opportunities that I have in my hand are the ones for Europe, but we don't work only for Europe, we work globally. We are truly a global organization. We have partners from all over the world, and we have the Galileo Teacher Training Program. We have the Global Hands-on Universe, which is a group of scientists producing real research exercises for people to use. The Galileo Teacher Training Program that is training teachers. GOGA that is bringing GoLab to Africa. And the PLO, which is the Portuguese Language Office of Astronomy for Development, that we coordinate in Núcleo, so we organize events for all the Portuguese-speaking countries. And this is part of the Office of Astronomy for Development. And with that, I stop and I will pass the word to Sandra, who will continue the presentation talking about this global effort, which is a truly important effort and is available to everyone in the world. So Sandra, I think I stopped in time for you to take over the floor. And please, the floor is yours.
Okay, thank you, Rosa, so much. Very inspiring presentation as always. And in fact, everything that you just commented is connected to what I'm going to present also right now. I'm just going to share my screen. Just 1 second. Okay. I hope you can see my presentation now. Can you see my slides?
Yes, we do.
Yes, great. Yes, so in the following 15-20 minutes maximum, I would like to present to you this idea of astronomy for development, which is really a global effort that has been going on already for many years from the astronomical community to actually contribute to make a better world. And there are different ideas on how to do that, but let me first present to you, probably you already know them, the Sustainable Development Goals defined by the United Nations, which are these 17 goals that are supposed to be fulfilled within the next decade. So this is a set of adopted priorities globally, so all the countries are adopting them. With the long-term goal of ending poverty, preserving the planet, and also acting against the climate change, promoting peace and common understanding between countries, between cultures, and at the end, looking prosperity for all humans in this planet. So as you can see, they are quite diverse. We go from zero hunger, concerning about health and well-being for everybody, to quality education, gender equality that was already mentioned, reducing the inequalities amongst different groups, vulnerable groups, or marginalized groups. It has also to do with decent work and sustainable economic growth, or for example, promoting peace, justice, and strong institutions. So there are different things that are involved in these goals. And of course, science, and particularly astronomy, can contribute to this. And the International Astronomical Union actually has, as already Rosa mentioned, has this Office of Astronomy for Development, which has the goal since the last 10 years of actually giving the resources to the astronomical community to develop different projects in order to tackle some of these challenges. The IAU has other offices as well, one for communication and outreach, a newly established one last year about education specifically with a lot of resources there, and also one for training young astronomers. But I'm going to focus now in the Office of Astronomy for Development. So this was established in 2008, and the idea was exactly to implement the IAU strategic plan. And why astronomy? Because we have already discussed during the week how inter and multidisciplinary this science is. You can go from the science and research part that involves the different disciplines like mathematics, biology, chemistry, and of course physics, also to all the technological and skill transfer that you can do to society concerning the big infrastructures, for example, the big observatories, or the instrumentation that has its basis on optics, on electronics, on engineering, also all the big data, or the handling of the huge amount of data that we need in astronomy. But astronomy also has a human connection that is very powerful, and maybe other science, they don't have this connection so obvious, that for astronomy it's very obvious that it really goes to our roots as humans, right? Because many civilizations have always looked up the sky to try to understand our origins and why are we here and what is the universe and what is our world. So astronomy also connects with this inspirational part, and it's a very important tool to build first global citizenship. So this feeling that we are all under the same sky, as Rosa also mentioned before. And also for education, it's very practical because it's a gateway to other sciences that may appear a bit drier or harsh for the students, but through astronomy, we make them very appealing. So the Office of Astronomy for Development is trying to have all these aspects together to be able to facilitate resources for the community, so we can actually now act concretely on using astronomy for development and trying always to benefit the society. And for that, they have an annual call of proposals, and in the last years, they have already funded more than 200 projects globally as well, and they have established 11 offices around the world. So here you see a map where all the projects from 2013 to this year have been funded, basically everywhere in many countries in most of the continents. I think only Australia is missing, but a lot of voluntary efforts from not only astronomers, but also teachers and other people that are actually using astronomy to make a better world and for development. So this is not only restricted to the astronomical community, although it's impulsed by the IIU, but other people can also participate from this call of proposals if you have a good idea to use astronomy for development. And these are the regional offices. As you can see, there are quite a few. We have, for example, the Andean region that is based in Colombia, or we have the Southeast Asia, for example, based in Thailand, Southwest Asia in Armenia. So in each region, we have a regional office that is giving a specific support to all the projects that are happening in the area. We have also one that has been newly established in Europe. I am actually the Spanish representative to this node, to the European node. And the idea is now to start giving support to all the European countries that are part of this office, also to start doing projects with this framework, within this framework. And there are also other kind of offices, as Rosa was mentioning, that are not only defined by regions, but also by languages. So there is this Portuguese-speaking node that is based in Portugal, but of course is involving countries also in Africa, or the Portuguese-speaking countries in Africa, and also Brazil. And they are really making an incredible work to integrate all these countries to promote science and astronomy, and also different projects that are being really incredible. And maybe, Rosa, you want to comment on that a bit later. Go ahead. But astronomy for development sometimes can be a concept that is a bit abstract, because when you see all these goals, you say, okay, but how can I actually use astronomy, for example, to contribute to decent work or economic growth? But there are actually many, many programs that are tackling these different goals. For example, some of these funded projects had to do with astrotourism, and they contributed to the innovation and the growth of infrastructure in different countries. Also, the projects had to do with community programs that were running in professional observatories, and these were also related to on how we actually clean water and the sanitation of the area, or how we build sustainable communities, for example. Other activities were targeting disadvantaged groups, trying to reduce inequalities. Of course, all the projects that are against light pollution and preserving dark skies are against climate change, and they are trying to obtain affordable and clean energy. So there are many, many things that within the framework of astronomy you can actually do to tackle these goals. And the ones that I'm going to present you next are mostly included in the 10th goal, and also in the 16th one. So using astronomy for diplomacy, so basically using astronomy to bring communities from different cultures, from different countries that maybe are in conflict, and they use astronomy to try to resolve these countries, or activities that are really trying to include all these groups that have been traditionally excluded from science and from astronomy. As you can see here in this graph, there are many ideas that you can put into place. And of course, if you have already ideas or you want to contribute to projects that are already going on, you can go to the website of the OED, check out, and also be aware of this call of proposals that will give you the resources to actually carry out all these projects. So here just some examples of things that are going on here in Spain. For example, well, Rosa already talked a little bit about this project, but there is this amazing Touch of the Universe project carried out by Amelia Ortiz in the Universidad de Valencia, also together with Lina Canas. And they have developed a tactile kit for visually impaired children and other materials as well, in order for them to also learn about the cosmos, about the universe, and facilitate access to this kind of scientific knowledge to this visually impaired community. we are now together with the Spanish Astronomical Society building a program for capacity building in astronomy that will connect Spanish institutions to institutions in East Africa, thanks to the work of my colleague Mirjana Kovic, which was also here at the IIC for some time. And we are also tackling some of the development goals within this collaboration that hopefully will start very, very soon. So some ideas that you can actually do within the astronomical community. But now I would like to present you in a bit more detail a project that actually I coordinated from here, from the Instituto de Astrofísica de Canarias, which is the work with refugees that are in a long-standing situation, the Sahrawi refugees. This is an initiative called Amanar, and we have been working last year, and we continue now trying to find more resources through the Office of Astronomy for Development to be able to continue the project and make it sustainable in time. And this is all pure voluntary. So this is a side of the daily job that I do here at the IIC. Of course, I have the support, but just to let you know that most of these initiatives are voluntary, and the OID provides you the resources to actually carry them out. For those who don't maybe know about this conflict, the Sahara, the Western Sahara, was actually a former Spanish colony. And well, they faced the colonization process that failed, and also an invasion that led to a long war. And in the 90s, the UN established a peace plan that unfortunately hasn't come to happen at the end. So what we have is a large group of refugees living now in this part of the Sahara Desert located in Algeria. We have around 200,000 refugees living there. From them, 40,000 are children and youth. And they are in a very uncomfortable situation because it's both temporal, so their refugees is supposed to end at some point, but they are also permanent because they have been there for already 4 decades. And they face many challenges in these refugee camps, as you can imagine. Of course, all the humanitarian, or all the resources they have come from the humanitarian aid. There is very small trade and economy. And the situation in the camps is quite traumatic sometimes. They don't have access to water, to fresh food, or even medicine supplies. And especially for the youth, it's very frustrating because they don't have the opportunity to study higher education, and also they don't have much prospects for their lives. So it's really frustrating for them, and actually depression rates are going higher and higher every year in the camps. So then we designed this project, Amanar, with different goals, but the first one would be to support the Sahrawi community, to support specifically the educational community. So we are working closely with the teachers, with the schools, providing all the materials that they are lacking, and also trying to provide inspiring activities and empowering activities for the youth so they can somehow escape the harsh reality that they are facing continuously. In a long term, we want to promote an improvement in the quality science education in the region by capacitating the teachers and giving them all the necessary resources to actually teach science and use also science as a development motor. And we are also working with the locals in order to study their own astronomical knowledge, because the Sahrawi community has a very interesting interpretation of the sky that is not lost. So the old people still have this knowledge. And we were also working together with them in order to preserve this knowledge and also to be shared within their own community with the young people, so it will not get lost with time. So here there are some pictures of the activities that we did first in the Canary Islands, because actually there is this program in Spain and other European countries that is called Holidays in Peace. And every summer they bring groups of children between 8 to 12 years old to different areas in Spain and also in the Canary Islands. And we wanted to give them the opportunity to have a day in which astronomy was the motive to bring all these people together, the Sahrawi refugee children that were visiting and also their host families. So we went with them to visit some of the observatories that we have here in the island. We did fun activities, memorable activities, where they had a lot of fun and they could create their own solar system, their own planets, different educational activities to try to motivate them and inspire them. This was done in last year. And then, well, here you have some pictures also of the moment where Spanish and Sahrawi children were actually sharing together one of the activities, looking through a telescope for the first time. That was really something very nice to see because some of these children had never seen a telescope. So they were really charmed about this, and also doing different kind of practical workshops where they could also actually be creative and have fun together. And then in October last year, a group of astronomers, educators, and also experts in ethnoastronomy, we traveled to the camps and stayed there for 2 weeks, visiting the school, donated a lot of materials because they lack even the most basic that you can imagine, like geography maps or of course, science labs. They are really restricted there. They don't have the materials there. So we brought a lot of instruments, materials, telescopes, so they can actually carry out different inquiry-based activities with their students. And of course, the teachers were the most important, or one of the most important parts of the project. We were doing these trainings in the afternoons after the activities with the students had finished. And as I was saying, we donated some equipments that remained there at the schools, and we trained the teacher in order to be able to use them. As you can see here, a telescope or also even an interferometer, which was very interesting for the science teachers, which they really had very little means. And as I was saying, we were collecting data on this different approach to astronomy that they have. They actually define a specific system based on the visibility and risings of different stars. And they use this system in order to predict atmospheric conditions, to orientate themselves in the desert, and also for religious practices. So all the tradition that they have is oral, and they have been transmitting from generation to generation orally. But we wanted to actually record it and to have it, to have the expert actually collect the data. So now it can be preserved, and now we are actually producing different kind of educational products so that they can also use it in the schools with their own students, with their own youth. And I think, yeah, well, one of the most important things for us was also to have this feeling of global citizenship for the children, because what they told us when we were there is that sometimes they feel like they have been abandoned by the international community. Very little people know about this conflict. They don't understand what is going on. They don't know there is these 5 refugee camps in Algeria where a lot of people is living. So they have this feeling that nobody cares about them. So through astronomy, we wanted to try to make them feel integrated in this global community and heard. And all the audiovisual products were also in this direction. And actually, we did a very nice activity that actually I recommend this activity not only in projects that had to do with astronomy for development, but in any activity that you want to do maybe with your students in your school, which is called the Voyager activity or the Golden Record activity. And basically what the students have to do is to reproduce the golden record that is traveling together with the Voyager missions that have been traveling in the solar system for more than 40 years. And what we invite the students to do is to create their own golden record and put there everything that is important to them from their community, from their culture, how is their daily life, something that really represents them as a community. And this was really very inspiring for them because actually it was a way to appreciate their culture, to make them feel important, and the different groups were then presenting to each other what they have decided to put in the record. Some put music, some put songs or animals or food. So this was really enriching, and it's an activity that we have been actually doing in other projects as well, in places in conflict. And it actually works very nicely to try to bring together different communities and to understand each other better. So this is a very nice activity that I would recommend also. Maybe it's interesting for you to do in your school. And for us, it was very important to involve the astronomical community, and this is the whole purpose of the Office of Astronomy for Development, to actually involve the professional astronomical community into these projects, because we cannot stay away from society. We cannot be in our labs, in our observatories, and not care about what is going on in society. So we need to get closer to the public and try maybe to contribute to this kind of projects. And now, if you allow me, just very briefly, I wanted to show you the trailer of one of the products that we are now working on, which is a virtual reality video that we are planning to launch in a few months. So this is a quite innovative product that we think is going to create an impact in the international community. And I just have the trailer here, so just let me share it just very quickly. I hope this works. Just 1 second. Okay, can you see my screen?
Yes.
Okay, great. So let me see if the sound works. Oh, wait, I think I have to share it.
Yes, with sound.
With sound, yes, just 1 second. Okay.
You have to select the drop-down menu, share optimized. Yeah.
We don't see it. Sandra, you might have shared the wrong desktop or the wrong screen. Perfect.
Buenas noches.
We didn't listen. We didn't listen.
Y cineastas. Venimos con un proyecto de divulgación y de educación de la astronomía. Pero estamos muy interesados en aprender sobre astronomía. Y nos han dicho que ella es una sabia que sabe mucho de astronomía. Entonces venimos a que nos enseñe y nos cuente un poco de lo que ella sabe.
ولا مرحبا بهم وسهلا. نعرف عنهم معاناتهم كبيرة، هذا اللي قطعوا ذا من الأرض وذا من الحمان وأعطاه هذا الأرض باش يفيدون احنا ونفيدوهم هم اللي بدل يا ولد عندهم بقى شي يسووا له.
¿Quieres preguntar algo?
Sandra, we didn't listen to you. You change something on the microphone because you are not muted.
Hello, can you hear me?
No, perfect.
Okay, sorry about all the technical issues. So this video is basically just a trailer of a full movie, virtual reality movie, in which we want to actually tell all the astronomical knowledge of the Sahrawi community. And the user will have the Googles and will be able to move around, see how the camps are. So this was just the center where we were staying while we were there in the camps. But the idea is that the person that is actually watching the documentary can actually move around through different places in the camp and can hear the stories of the stars and the constellations from the different wise and old people that we interviewed there. And this is something that we are doing actually in collaboration with also the Sahrawi people that went there with us. So just an example of one of the projects that we are doing together with them. And with this, I just finish. I don't know, Rosa, if you want also to complement something on the pilot work that you have been doing.
No, I think, thank you, Sandra. I think we are already on the hour. I'm surprised that David didn't ring the bell to us. So, well, I think you presented your work and the work of the OED. I think the work of the OED is very important because for the first time, we have this large network of people around the globe, not only for education, but for development, for outreach. And I think this is truly important because then, you know, the world becomes much smaller. We can, we easily find someone that can help us somewhere, and also to bring the cultural aspect and the social aspect that we might not be seeing properly. So this is really, really very good. And I think we are over time, so I think we give the floor back to Michel or directly to Gustavo.
Yeah, Rosa. Perhaps we can make now a picture.
Yes, that's correct. That's correct. Yeah, so now I ask everyone to be very brave. We have 72 participants here, and we want to do something that we do in all gatherings like this, which is a group picture. So all of you that are not afraid in showing your faces in social media and say, I was a brave participant of the Galileo Teacher Training. These are Galileo Teacher Training Program training. Can you please turn on your cameras? Everyone, please. So we do want to show that these were not machines made. These were really people that were there with us. And this to make all the difference. Actually, next time, I think I will oblige everyone to have their cameras on all the time so we can see people. We see that you are not asleep. You are alive. Oh, that's so super, super, super cool. Thank you so much, everyone. So let's make sure that we have our print screen or print screen ready. Everyone can take a picture if you want.
Some are saying, someone is saying that it is in her pajamas, but I don't think that's any problem.
Who cares? I don't see a problem at all. I mean, I work in my pajamas every day. Well, except when I have this type of meetings, I don't. Having pajamas or kids. So yeah, let's give one more minute. Everybody ready? So the photographers ready?
I'm ready.
Okay, so let's
you
go,
have
people.
to get a smile during 4 seconds.
Okay, and you have more than one screen, so wait with your smile there. Yeah. Okay, shall we go?
3, 2, 1.
We have several windows of people. Not everyone is with their cameras on. Two clean screens also, David, if something goes wrong with yours.
Okay.
Thank you, everyone, for giving life to this. It is nice to see you all.
Okay, it's done.
Thank you. Thank you, David. Thank you. Okay, so Michael, they're yours.
So good. So we come to the next talk. Also a quite interesting one. So we have Gustavo Rojas, and he will tell us how you can hunt satellites. So we heard before that satellites are becoming more and more common. It's even starting to be a problem for astronomers. You take a picture and you have satellites in your field of view. And then you might want to know what satellites they are. So Gustavo will tell us now how you can get them and how to know which satellites they are. So Gustavo.
Yeah, thank you. Can you hear me well?
Yes.
Good. So thank you for the opportunity to give this talk. We had a great presentation this morning by Beatriz Rilete. I confess that some of the content that she presented are already in my presentation, so I won't be too much detail into satellites. I just give an overview because Beatriz really showed a lot of interesting stuff in her talk. And the idea is really just to show how we can observe the satellites. In this case, they're our focus of interest. We understand that satellites are becoming a nuisance to astronomers because they're interfering in the observations, but it can also be subject to kids and to make predictions. It can be really a very interesting activity. So I'm going to share my desktop now. Please tell me if you can see the desktop. Sorry. Sure. Okay. Clicking here. Do you see it? Not yet, right?
Not yet, Gustavo.
Okay. So let me try again. So
it's coming. It's not here yet.
Okay.
Okay, now we see, but not in presentation mode.
Yeah, yes. That is not exactly what I planned. I wanted to share the whole screen, but no problem. We stop and go back again. Yeah.
It's perfect.
Good.
It's perfect.
So let's just start. And so here's the brief outline of my talk. I just opened the space on Grasp. Okay, so I will use some of the links that are in Grasp. So I'll take some minutes to get there. But meanwhile, you can open the Grasp in day 5 and go for my space. I'll give a brief introduction on what satellites are and why they're important, some history, then some physics, because there are some interesting physics topics that are related to satellite motion, discuss some of the orbits and types of satellites, and finally, how do we observe it and how we hunt them. That will be the fun part. So it's going to be just about 10 to 15 minutes talking about this broad subject and then go to the hands-on session. So satellites are part of our everyday life, right? Even if you don't realize it, we are using them all the time. It is really become a characteristic of our age. And we had incredible advances since the first satellite was launched in the 50s. And we really cannot think of our everyday life without the satellites. We use it all the time. And this is really an interesting topic to discuss with the students. So if you are teaching space technology with your students, if you're bringing the subject, you can begin by asking these questions. Can you name it one or more of your everyday activities where satellites play an important role? So I'm going to ask these questions to you now. So if you can use the chat, I have another computer here so I can monitor what you're putting on the chat. But I'd like to, if you can give me some examples of where we use satellites on our daily lives. Okay, here's here TV. What else? Mobile phones. What else? Let me see here. GPS, good. Yes, navigation. Yes, you see that we can spend minutes and minutes here discussing what kind of applications we have for satellites, but it's really used for many purposes, mainly for communications, Earth observation, and also astronomical observation. They play an important role because some kind of astronomical observations can only be done above the atmosphere. For instance, in X-rays and gamma rays, the atmosphere protects us. So to explore the universe in these wavelengths, we need to be above the atmosphere, and this can only be achievable by using satellites. So this is a very interesting topic to bring to the students so they can think about it and see that really satellites are everywhere. Okay, so sorry. So just a little historical background on how we reached there. So the first person who realized it, that was possible to have something around the Earth was Sir Isaac Newton, who developed the theory of gravitation. And there's this famous figure on the top right that shows his reasoning. He didn't use the word satellite, but he was thinking about a cannonball, that the faster you launch that cannonball, the farther it travels. So if you launch it with enough speed, it will never hit the ground. It will be circling around the Earth indefinitely. So this was in the 17th century, and Newton was the first one that discovered that a satellite was possible. And he also discovered that the moon was a satellite of the Earth. And this idea was later being put in use in fiction. So we have some writers in the 19th century that explored this idea, such as Edward Hale and Jules Verne, who used the idea of, can we have satellites? What can you do with these devices that circle the Earth? But the things really changed in the 20th century. First, by the work of Tsiolkovsky, who developed the rocket equation, the physics principle that shows that you can, how can you achieve these speeds that are very large to launch an object to the orbit of the Earth, followed by the development in rocketry. So one of the pioneers was Robert Goddard, who developed the first liquid rocket fuel. That's a major improvement over the previous tries that was based on gunpowder or other explosives. So when liquid fuel arrived, it really changed the scenery, and that had an impact in the Second World War. For instance, the development of missiles such as the V2, the flying bomb, and that led also to the advances for the space age that came later. But the idea of satellites, they were first seriously proposed by the fiction writer Arthur C. Clarke, who was the first one to propose the geostationary satellites as a means of communication. So he published his short article in 1945, just after the war, showing that if you put satellites in orbit around the Earth, they can be used to relay information for the whole planet. And eventually we reached that scenario. But the space age, it started when we had the first artificial satellites launched in 1957 by the Soviet Union, is Sputnik 1. I know you know this story very well. So this is also an interesting activity that you can propose to your students to build a timeline of space exploration. You can begin way back in the past, such as I did, or you can also use a modern timeline of the space exploration from Sputnik to now. So there's a lot of things to tell here, a lot of stories, but I just give this background here so we can see where the satellite story started. Now, I don't want to scare you, but I always like to put some equations in the presentation because these contents, they can be presented at high school level in the framework of circular motion, which is one of the first things we learn in high school in physics, in sciences. And the principles are very simple because the orbital motion, it can be simplified as a type of circular motion where you have the satellites, the orbiting bodies on a circular path around the Earth. And the only force that is in action here is the gravitational force. So if you write that the gravitational force is equal to the centripetal force, the mass times the centripetal acceleration, you can get an equality in the right side that allows us to derive some interesting relations that we can use. We can put numbers there and let the students work and to see some of the results that they can achieve. So in particular, I'd like to highlight these three equations on the bottom of the screen. The first one is the orbital speed equation, which you can, when you isolate the velocity on this on the force equation, you can isolate the velocity and you can calculate the velocity that an orbital body has as a function of the mass of the planet that is orbiting, in this case the Earth, and as a function of the orbital distance. Remind that this distance r is the distance to the center of the Earth. So if you want to know the altitude, you need to subtract the Earth's radius from r. But if you say, oh, this satellite is orbiting the Earth at altitude of 500 kilometers, you can plug in the numbers there and calculate the velocity that a satellite orbits the Earth in this many thousands of tens of thousands of kilometers per hour. It's a very fast speed. Another interesting equation is the orbital period equation. So if you consider that the orbital velocity is just the circumference of the path, it's 2 pi times r divided by the period, you can isolate the period and manipulate the formula so you can arrive at the period of the satellite. So how much does it take to make an orbit around the Earth? So this is irrelevant. It will be dependent on the orbital radius. So the higher the orbit, the more time it takes to complete an orbit around the Earth. This will be relevant for some special cases of orbits. And finally, the orbital radius equation, which can also be achieved by manipulating the initial relation, and that we can arrive at a specific altitude for our purposes. So these are some kind of physical equations that can be worked in your science class or in your math class, and to have the students have a feel for the numbers and see why they are relevant. But okay, that's enough. Those are the only equations I'm going to show you. So sorry. Oh, it's not here. Okay. What is happening here? Okay. So let me discuss briefly the types of orbits that we have. So when we see a picture like this, I think this is the way that most people think about satellites, that they orbit far away from the Earth, but this is not always the case. Because most of the satellites we have in orbit are in the so-called low Earth orbit. So they're relatively close to the surface, and they are just above that atmosphere, a few hundred of kilometers above the sea level. And this definition is comprehends the satellites that are up to an altitude of 2,000 kilometers. So everything that is below 2,000 kilometers of altitude is considered in low Earth orbit. And the vast majority of the the satellites that you have around the Earth are in low Earth orbit. And that includes some of the most known objects, such as Sputnik 1, the first one that was launched, which orbited at 215 kilometers above sea level. The International Space Station, where the astronauts are right now, that is 340 kilometers above the Earth. And the Hubble Space Telescope, here you can see it being put in orbit or repaired, I don't know, by the Space Shuttle, which orbits at an altitude of just under 600 kilometers. So this low Earth orbit has many advantages for some kinds of purpose of satellites, because if the satellite is closer to the Earth, for instance, for communications, you might want it to be closer to the Earth because then you don't need a very high power transmitter for the satellite, and also the latency of the communications, the time that it takes to information to be relayed and back, is also smaller. So in applications that really need very low latency, such as internet, for instance, internet communications, you want your satellites closer to the surface. And also the space station, because you want to reach the space station very quickly. You don't want to travel a long time to reach the station. It needs to be closer to the surface. So most of the satellites that are in orbit of the Earth are in low Earth orbit. And we have a special case of this orbit, can also be applied to other longer orbits as well, that are called the polar orbits. These are orbits that cross the Earth's pole or some regions very close to the pole. And this has several advantages. But that it crosses the equator almost perpendicularly. And they cross also the intersect the Earth's surface at a given latitude at a given time. So they are very useful to make Earth's observations, some kinds of Earth observations that you know that will be above a certain latitude, longitude at a given time. So it is a kind of orbit that is very used to some kinds of satellites. So it's called the polar orbit that is crosses the Earth pole or very close to that. If you are above low Earth orbit, above 2,000 kilometers, then you reach what you call the medium Earth orbits. So this is a very vast region of space around the Earth, which ranges for 2,000 kilometers to the limits of the geostationary orbit, which is 35,000 kilometers. What is the geostationary orbit or geosynchronous orbit? This is when you are so far away the Earth that the time that the satellite goes around the Earth is equal to the Earth's period of rotation, or the sidereal day. That is just below 24 hours. It's 23 hours, 56 minutes and 4 seconds. So if you are at that specific distance from the Earth, 35,786 kilometers above the surface, then the orbital period equals the sidereal day. So the result is that the satellite follows the Earth perfectly and is always at the same position at the sky for a given observer. So these are the so-called geostationary or geosynchronous orbits for satellites. That was the orbit that Arthur C. Clarke proposed back in 1945. And these are used for communication satellites mostly, or also meteorological satellites that need to observe a certain region of the planet all time long. They cannot move, so they observe the Earth from a fixed point of view. So is a very important orbit, is the geosynchronous orbit. And so this is the limit of the medium Earth orbit. So is where the geosynchronous orbit is located. And there are other different types of orbits that are in medium Earth orbit. An interesting type is the semi-synchronous orbit, which is about half of the distance of the geostationary orbit, and it is used by GPS satellites because it's a highly predictable orbit, and you know that it's going to cross the equator 2 times a day at a fixed longitude, so it's very reliable to be used by positioning satellites. And above the geostationary orbit is the high Earth orbit. So everything that's above the geostationary limit is called high Earth orbit. Now here comes another question. Can you name it something that's in high Earth orbit? Let's see who answers first this question. Can you name it anything that is above high Earth orbit? Any guess? Soho. Yeah, Soho, I think, is on the orbit of the Sun, not on the orbit of the Earth. Something that is orbits the Earth, not the Sun. I give you a clue. You can see it during the night very easily. And it's very large. The Moon, exactly. Well done, Irving. The Moon is on the high Earth orbit. It orbits the Earth, is very far away, but it still orbits the Earth. So the Moon as example is not an artificial satellite, but it's a natural satellite that orbits the Earth in high Earth orbit. So I'll show you this image that gives in scale the position of these different orbits. So we see just close to the surface is where most of the satellites are, very close to the Earth. And so you don't see the whole Earth from above. And this is where the low Earth orbit. The green area here is the middle Earth orbit, and the red zone is the high Earth orbit, is after the geostationary orbit. And you can see on the bottom of the screen where the Moon is located in a different scale. So we can see that the high Earth orbit is much larger than the medium Earth orbit, which is much larger than the low Earth orbit, just to give a sense of scale of these things. And we see that there's a lot of space around the Earth where things can orbit. All right, so let's continue. So let's discuss now some kinds of interesting satellites. As I mentioned, most of the satellites are in low Earth orbit, and we are familiar with them. We are like the Hubble Space Telescope, International Space Station, communication satellites. So these are the satellites that are most used. But there are some special kinds of satellites that are worth some mention. And one of these types are a more recent type of satellites. It's a group of satellites that are called the satellite constellations. And this is indeed the type of satellite that is raising some trouble for the astronomical observations, because there are so many of them that it is affecting some observatories. And this is probably saw that before, but this is an example of the most numerous constellation that is being launched during these years. This is Starlink. It's a fleet of hundreds and hundreds, if not thousands, of artificial satellites in low Earth orbit that are for internet access around the globe. And we can see here some of the impacts of these satellites. This is mostly during after the launch, when the satellites are still reaching the orbit and they're all moving together before they're put in the final orbit. But on the right, you can see the impact of these satellite trails on professional astronomical observatory. This is a camera from the Dark Energy Project, which is telescopes located in Chile and other places. So you can see it's a mosaic of CCGs, and you can see how many satellite streaks from the Starlink constellation can be seen. So this ruins the observations. Of course, this cannot be seen all time. It's mostly after sunset and before sunrise. So in the middle of the night is not a huge problem, but of course it impedes some kind of observations during the start of the night and the end of the night. And on the left, another example of this is Neowise comet, the comet that was visible in July, and for astrophotographers is really also a bad thing. Someone here mentioned also for radio astronomy is also a problem. So this is really something that has been raising serious debate of the impact of these artificial satellites, and the tendency is that this is going only to get worse as things progress. Here's just a video to show you the launch of a satellite fleet. This was imaged in Leiden in the Netherlands, and you can see each bright speck here is a different satellite of the Starlink. So it's very impressive, the effect of these satellites, and also be an amazing view. I haven't seen a Starlink trail yet. I haven't had that chance, but you can imagine people that don't know what it is and start seeing the sky, they should be really scared. So, oh my God, it's an alien invasion or something like that. But this is a capture earlier this year in the Netherlands. Another thing that is in orbit, but is not a satellite, it's not a constellation of satellites, are space debris. So as you can imagine, there must be a lot of space junk around the orbit of the Earth. In fact, Beatriz Helete talked about the safety that is involved in every space launch, and how do you monitor these fragments that are in orbit of the Earth. This includes rockets that were used at the early stages of the rockets, fuel tanks, fragments, old satellites that don't work anymore, objects that astronauts lost in space, you name it. There's really thousands and thousands of objects that are in the vicinity of the Earth, and they also need to be monitored and also can be observed if the sun shines on them and at the appropriate angle. So this is and sometimes they fall on the Earth, right? So this is a very nice picture of one of these space debris. This is a piece of the Long March 3 Chinese rocket that is used to put satellites in orbit when it made the re-entry in the Earth's atmosphere, and it breaks apart and burns. And luckily, it didn't hit anything, fell in the ocean, but its photo was made on Hawaii. But sometimes these objects, they hit the surface of the Earth, and they can really sometimes hit inhabited areas. Luckily, it didn't have any casualties for space junk falling on the Earth, but as the number of the artificial satellites increase, the number of space missions, this is a risk that we carry. Okay, so that was my introduction. Let's go now for the fun part. For how do we observe this? So the purpose here is I show you some tools of how we can plan observation of satellites, and how do you use these tools so you can use it again with your students, with your friends, and make the most of the fun of observing artificial satellites and show people. Some people think it's like magic because, how do you know that? How do you know that satellite is coming now? So there's a few secrets that I'm going to show to you. So the best tool available is Heavens Above. This is a website that has been around for some time and gives very precise predictions of not only satellite passes, but also provides astronomical charts, information about comets, the planets. So there's a lot, eclipses, moon phases. So there's a lot of information here in this site. So if you don't know it, go visit after today's session. You'll be amazed at how much content and how much information you have in this site. But the most important thing here is that it provides the tools that we want to use now for making the prediction of satellite passes, and is also available as a mobile app. And so, but it's only for Android. Okay, so if you have an iPhone, I'm sorry, it's not available for iPhone, but it's available for Android. So you can also download it and use on the field. Is much more handy than bringing a computer to the observations. So let's now I'm going to stop briefly sharing my screen, and because I want to share the browser. Please, I'm going to copy the link here on the chat for Heavens Above, so you can visit the website. If you don't have an account, you create an account. Okay, someone Muhammad out there. So my screen, Google screen. So I had another account that I want to make an account from scratch, so you can see how you use it. So when you make your account, you don't have a fixed location. So here you put all the observations as they were in the latitude 0, longitude 0 at sea level. So we are not there. I think nobody's at that place in the middle of the ocean. So let's add a location. So when you click a location, you can also change the language here if you want. It's available in many different languages. If you go here in the configuration, change your observation location in other settings. So a new location. The location from your browser. Place here, type Oeiras, where I live now, in Portugal. It's not exactly there, but we'll do for today. Or you can use also the latitude and longitude, or you just can click on the map to set your location. And also the time zone. So it's now on my locations list. And the good thing is that you can add, I think it's an infinite number of locations. I had never tried that. No matter other accounts, I have dozens of locations. So it's very useful if you go travel to somewhere to make observations, you can put that particular location so you don't have to enter it at the time. So now that I have my location set, we are going to see so here a lot of options. You have live sky view, which is like Stellarium, that gives you the sky chart for this moment. You have options to see the orbits of Starlink or the International Space Station. But I'm not interested in that now. I just want to show you what you probably use most of the time. That is the daily predictions for the brighter satellites. So click on this option and you're sorry, I clicked the wrong button. So this is the prediction of the satellite are going to be visible this evening. Okay, so it's still daytime here in Portugal. So it is if it was already the middle of the night, the website will select the morning or before sunrise, but it's not the case. It's evening. And here you can select also the minimum brightness. So as I live in a city, I'm not going to go for the faint objects. I'm going to see just the bright objects from magnitude 3 or below. So it's another list. And then we have this information. So these are the brightest satellites that will be visible from my location in Portugal. And then you have a bunch of information, but I'm going to just go very briefly. This is the name of the satellite or the debris. say the rocket is not a satellite, it's a rocket that is orbiting the Earth, but is a space debris. You have the brightness, the magnitude, so you know that the lower the number, the brighter it is. So we have a very bright satellite here, 1.4, 1.8 is bright enough to be seen from the city. And you have the time that the satellite becomes visible, the direction that is in the sky. This is the highest point, so this is the most interesting part. We are going to explore it in a moment. So what is the maximum point in the sky that it will be visible, at what time, and when it stops to being visible. So what we are concerned here is to see, I'm going to pick the most bright one, the brightest one here. I'm going to click here. You have a link in blue with the time of the highest point in this orbit. So when you click here, it's a sky chart. So this is a sky chart of this passage. The satellite pass, the bright one. So we see that it's going to appear towards the south-southeast and going to cross the sky here. It's going to pass through these constellations, Aquarius, Pegasus, Cassiopeia. It will reach the brightest part, the highest part here at 20 UTC, and then go below the horizon 6 minutes later. So this is very useful, so you can predict where the satellite will pass, where to look, and if you want to photograph, also where to point your camera before the satellite passes. So if you know the sky, if you are in a dark place where you can see the constellations, then you don't need to very much more than this chart. You just look here for Pegasus, which is a very remarkable constellation. So I'm going to look at the direction of Pegasus around 8 p.m. and then I will see the satellite passing by, crossing the square of Pegasus. But if you are in the city, that might not be so easy because you don't see so many stars. Then we can have the other in the altitude and azimuth. So these are two astronomical concepts that I'm now going to stop again and share my PowerPoint again. Let me go there. Okay, so let's continue here. Just to you probably know this, but some of you might not know what altitude and azimuth is. But it's very simple. Altitude is the angle that relative to the horizon. So if something is in the horizon, it's 0 degrees. If it's above your head on the zenith, it's 90 degrees. So this is the approximate angle relative to the ground that the satellite will be when it's highest in the sky. And the azimuth is the direction relative to the cardinal points, north, east, south, and west. So traditionally, you count positive to the east. So east is 90 degrees of azimuth, south is 180, and west is 270. Although there are some systems that are the opposite, but never mind. For heavens above, you always count clockwise from the east. So just to put this, this is the figure that you show the concept of altitude and azimuth and how the azimuth relates to the compass. So if you are in a bright side, or if you don't know the constellations, you can use the information that here in the table of heavens above to know more or less the direction that you have to look to see the satellite pass. Okay, so now we are going to make a quick. We don't have much time left, I'm afraid, but I'm going to visit the link that I put on Grasp. I'm going to put the link here. Just hang on a second. So we have now a spreadsheet that I want you to go to heavens above, see what is the brightest satellite that it will be visible from your location, okay, and put in this spreadsheet. So I already did my part. I'm going to show that the brightest pass will be by this CZRB rocket that is going to be visible at 20 hours and magnitude 1.4. So I went to the spreadsheet and I enter my name. Good, I see there are some people there. So just make this exercise so you can see who wins, who can see the brightest object tonight or next morning if you're in a place that's already nighttime now. So let's make this comparison. Is someone going to be able to observe the International Space Station? That might be because it's passing over our heads every 2 hours. It will not be visible from Portugal this evening, but I know that someone might be. We are distributed all around the globe, so there's a good possibility that some of us will be available to see the International Space Station tonight, and it's very bright. If you haven't ever seen the ISS, you'll be amazed because sometimes it can be as bright as Jupiter or Venus. It's really, really bright if you are very close to the passage. So I see that Panajotis will see the same rocket as I do. So yes, keep playing, keep doing this. I'm going to continue with the presentation. You can view it later, after, but it's good that everyone makes this exercise. So and after you can practice. If you don't practice today, you can practice tomorrow, during the weekend, whenever the sky is clear, so you can get a feeling of how it works. And you see that after just sometimes. It's you'll be addicted to it, of hunting satellites by naked eye, see they passing, identifying them, showing to the other people, which is very interesting. Okay, now I'm going back to the keynote while you fill the spreadsheet. So let's see what I have to show you. So you're already predicting. And there's a special kind of satellite pass that is very impressive. It's even brighter than the ISS. It's the iridium flares. So what is a iridium flare? It is a special kind of satellite, a satellite that is in a constellation of satellites that were launched during the 90s. And they have these very large solar panels. And then when the panels are at a specific angle between the observer and the sun, there is a sudden, very bright flash of light. So it comes very, very faint. And all of a sudden, for like 10 seconds or so, it gets very bright and then it dims again. So in heavens above, you have also the option to see what will be the next iridium flares. Some of them might reach magnitudes around -8 or -7, so tens of times brighter than Venus are. So it's very impressive. In fact, some of the brightest can even be seen during daylight. So but I recommend you try to see iridium flare during nighttime first, and then when you manage to locate it, you can try during the day. But it's really impressive, and if you show to other people, I'm sure they will be amazed to see how do you know that, how do you know when to look, where to look in the sky. And it's really impressive because it's very, very bright. So iridium flares are a special type of satellite pass. And you also want to look later if you want to put in the spreadsheet when the next iridium flare will be. We can compare the results. Okay, so let's continue. Yes, can you see iridium flare in location? If you can, let us know in GRASP or in the spreadsheet or here in the chat. And finally, another kind of prediction that we can make, although not very frequent, is space debris reentry. So there's a service. I have the link on Grasp. This company Aerospace, they have this service that publishes the reentry predictions. I know ESA also has a website with reentry predictions, but ESA is not as precise. What they give you is just the most probable zone of reentry, because you don't know exactly which orbit will happen, the decay. You know that they have a pre-orbit uncertainty, so it might be anywhere, and they circle where the most probable point of reentry will be. So this is going to happen tomorrow night, here somewhere over the Pacific Ocean near Indonesia, but it's not necessarily there. But it's also always fun to see if there's a reentry planet to your location. You can try to view it, because it's a very impressive phenomenon. Now to the final part of how to photograph. So after you learn how to predict the passes and you become used of accurately predicting and observing the passes, you can try to make some photographs of the passes or videos. So you don't need a fancy equipment to do that. Any digital camera that is equipped with a timer can do it. And it's better if you have a camera that allows manual focusing. So you can adjust the focus before, because the camera doesn't know that you are focusing on the sky. So if you don't have manual focus, it will be hard to make a good photo. If you can use the largest lens you have, I mean, the most wide, they gave you a wide field, so you can catch the largest area of the sky. So we do not recommend anything longer than 50 millimeters in focal length. And you need an accurate clock, because you don't want to miss the time of the pass. So there is this website that called time.is that is very useful, because it gives you a very accurate time, and you can use it for preparing for the observation. And you can use also a compass and an inclinometer to adjust the direction the camera will be pointing, using that information that I showed before on the table. But you can also follow the constellations if you're in a dark sky and know the constellations well. So, but if you're not secure about your knowledge of the sky, use a compass and inclinometer and it will work. And my advice here is that you make several test exposures before the satellite passes. So you can adjust the focus, you can adjust the time exposure, the ISO, so you can have a good photo. Remember that if you want to catch a long trail, you have to leave the shutter open for a long time. So, but if you leave it a long time open, you need to use a low ISO, a low sensitivity, because if you use a high sensitivity, the sky background will be very bright and you won't see anything. So make different tests, different values of exposure and sensitivity to achieve the better results for a long exposure, and point the camera to the star field you want to see. So to make sure you can make a picture of the star field, the constellation that the satellites will cross, and see the result beforehand, adjust the focus, because when it passes, you just have a few minutes to make the shot count. So these are some pictures that me and my colleagues have done some time ago. The one on the left was made with a fisheye lens, which is the most useful lens in this case. So you can have the whole sky in one single frame. This is a pass by International Space Station. This was done in Brazil. You can see the Milky Way there shining, and the beautiful southern constellations. The one on the right I made also from Brazil, from the university I worked at in São Carlos. I did not have the fisheye lens, so I made several short exposures, around 10 seconds each, because if I did longer, the sky background would be very bright. You see there's some light pollution in this shot. And then you see the the segments is each of the exposures while the International Space Station was crossing the sky. And this is a very impressive photo that I found, that this photographer, Mike Humpage, managed to catch 3 or 4 different ISS passings in one single day. So in some times of some epochs of the year, in summer, in high latitudes, you can see up to 4 passes in one single day. So this was registered by Mark. If you want to try now, after you train on the ISS, you can try to photograph iridium flares, which is much harder because you don't see it passing all the way. It flashes for just 10 seconds or something. So you need to really point the camera to the direction that will be, and hope for the best. So I tried several times and finally I succeeded. This was done from my backyard in São Carlos, and you can see the increase of the brightness of the satellite. So you have, it starts very dim, it increases the brightness, and then it dims again. And it all lasts 10 seconds or so, so it is very time sensitive. And now for the expert part. The most dramatic pass is when this International Space Station crosses the disk of the moon or the sun. So this is very location specific because there must be a perfect alignment, and you can make your prediction for the location using this website, is transitive/finder.com, that you give your location and you tell you if there's going to be a pass near your location for the next month. Doesn't make long time predictions because the orbit of the station is being corrected with some frequency. So, and also you have to be a skilled astrophotographer. You need to have a long lens or a telescope to make this kind of detail in the passes. So this is for more advanced users, but it might be worth a shot if you know that the station is going to cross the moon disk, for example. Even if you don't have a camera, just to see the International Space Station passing in front of the moon is a lot of fun. So I only have 2 minutes left, so I just show you what you can do with Stellarium. So Stellarium also has a database of satellites, but it's not as precise as a service like Heavens Above. So I don't recommend it to predict the passes because it gives different predictions. But you can show how it looks if you're in a classroom during the day, if you want to show how a satellite pass looks like during the night. So I'm going to share, it is the last part, and you can play it after to see how it looks in Stellarium. I'm sharing Stellarium now. So the point is that Stellarium has a plugin for satellites, but it's not activated automatically when you install Stellarium. So you have to activate the plugin. For that, you need to come to the configuration window, and then you have this information of plugins. There are a lot of plugins that you can use, and there's this plugin called Satellites, and then you have to click here, Load at Startup. So the next time Stellarium opens, it loads automatically this plugin, okay? And then if you click Configure, you have several options here, but the most important is the sources. So what kind of satellites you want to have in the database, because as you can imagine, there are thousands of them. So you have the Iridium, you have Starlink, you have GPS satellites, geostationary satellites, so you might want to try to play with that. And finally, to see the satellites on Stellarium, I'm going to put during nighttime here, so we can look for that satellite that would be visible from my location. And you have to turn on the satellite option here, which is somewhere I can't see. It's somewhere here. There is the option for satellite hints. You see there's this button here just below the date that you can click on and off, and then you can look for the satellites. I don't see any here. I don't know why, but okay, I can look for that satellite, specific satellite. You can type the name. So what is the name again? CZ something. Yes, CZ/4RB. You show the satellite. It's below the ground yet. So if you look closer, it will show you the position of the satellite. So this is how you turn on the satellite plugin in Stellarium, and you can show them. So it's kind of useful, and you can make it appear in your simulations. I don't know why it's not showing up. I don't know what I did wrong. But when it's on...
You have the option on. Can you show the menu below?
Yes, I can show you. Here?
No, in the shortcuts. Where are the satellites? I don't think you have it on.
Okay, so the plugins, yes, configure. Yeah, some of them I click it. I'm going to click all of them so we can see it.
But you have satellites, you have sources there, but you have satellites on the other tab.
At least you can see if you can turn on a specific one. So you see, this is displayed, so it should be above the ground, on the screen. Let me put labels. That will be.
Orbit lines also help you. And
yeah, this works now. You see the labels. Okay, so this is the one that I was expecting, CZ4RB, and you can see. So you have to turn on the labels, otherwise you won't see it. And you can look in the sky and look for other satellites passing by. Oh, here's a Starlink, our nemesis, and IFA radar. So remember, you need to turn on the labels. I will show you again how you do it. You go to configuration windows, on the plugins, satellites, and then configure and put on labels. So you can see the name of the satellite. That will help you locate because they are not very bright. Okay, so I have a guide on Grasp, so you can have a more detailed explanation on how to use this feature. And then if you have any doubt, you can also contact me. I hope you enjoyed this small presentation and have fun and practice, because practice makes perfect. Practice locating the satellites on the sky, then try to photograph them, use Stellarium, and the most important, share with other people, share how can they do it so they can reach their conclusions by themselves as well. So thank you for the attention.
Yeah, many thanks, Gustavo. Also very nice, really, to play around with it. I use Heavens Above mostly on the mobile phone when I'm outside. But it's interesting, I've never used the version on the computer, but I will do. And yeah, in Stellarium it's also quite nice to watch satellites. So other questions for Gustavo? I see a lot of thank you, excellent. Practice is important, yeah. I don't see any questions. Okay, if we don't have questions.
Yeah, just let me ask people to fill the spreadsheet so we can compare the satellites and see who sees the brightest one. Oh, Mert Koser from Turkey. He or she is winning now because there is a ISS passing there at magnitude -3.2. So this is the brightest one so far. So let's see if one can beat Mert.
Okay, very good. So let's have a short coffee break, the last coffee break, and then we are back at 5 o'clock Central European Summer Time. which is 3 o'clock Universal Time, for the wrap-up of this Galileo teacher training program.
Okay, welcome back from coffee break, everyone. I hope that you are prepared and full of energy for this last part. We have two things foreseen for towards the end of today's presentation. We have a small presentation about this Erasmus schools accreditation, which is more for European schools. It's something that is provided by the European Commission to support schools, but nevertheless, I think it's useful for everyone to check it out because it's in the line of the things that I have been presenting today to you. And then we have the open floor to discuss with you guys what are the future steps and what are the things that you want us to continue offering to you so that we can be prepared for the year to come and to support you the best we can. As I said, this is just the beginning of our journey together and not the end point. So in order to introduce the next topic, the Erasmus Plus accreditation, I will pass the screen to my colleague Maria Luisa Almeida. Is one of the founders of UQ with me, and thank you, Luisa, for agreeing to present this important topic. And I give you the floor. I have to warn you that we have David here has a very nice sound to tell you when your time is up. So don't be scared.
Oh my God.
In 2 minutes he will let you know. So the floor is yours, Luisa.
Thank you. I'm going to share my screen so that you can follow this short presentation. It's useful to have some links to what you will have to do and read if you want your school to be accredited. So I've asked Rosa, and I think she has already uploaded so that you afterwards you can also look at the links. I'm sorry for my voice. It's failing a little bit. So what is the Erasmus accreditation? This is very important because, as you know, Erasmus Plus has finished and we have a new program from 21 to 27. And if your school is accredited, it will be easier for you to apply in the key action 1. So that's for mobility, for staff, teachers, school staff, headmasters, and so on. There are 3 fields for the key action 1. These fields are adult education, vocational education and training, and school education. I'm going to talk about school education since I think that most people over here are work in schools. So the target over here should be the school education. Mind that the validation will be for the whole period of 21 to 27, but they don't expect you to fill in a plan for the whole period. You will be able to present your plan for 2 to 5 years, and then it will be updated periodically. There are different types of applications. You can apply as an individual or as a mobility consortium coordinator. But usually I would say that most schools would go for individual Erasmus accreditation. You do not need previous experience. So if you haven't still gone to any of the other calls, don't worry, this is for everyone. But if you haven't gone, you must need an organization ID. And I leave here the link for those that don't have, still don't have an OID so that they can apply for one. Those that already have should use the same one as always. There are certain goals that are common to all the 3 fields, adult education, professional, and school education. And those are the strengthening strengthening the European dimension of teaching and learning. So you should be aware that when you're applying, you should talk about values of inclusion, diversity, tolerance, democratic participation. Sorry. You should promote knowledge about the European heritage and the richness in diversity. And you should show that you're supporting the development of professional networks across Europe. So these are common for all fields. Specifically for the field of school education, I think you should have in mind that what they really want is to increase the quality of the teaching and learning by supporting the development of teachers, school leaders, and other school staff. So you should think that you don't want only to send teachers for your mobility programs. Think about the rest of the staff. The use of the new technologies and the innovative teaching methods, it's very important. The language learning and language diversity. So don't forget, the language diversity is also one of the main objectives. And of course, sharing the best practices. Also, there is this idea of creation of an European education area, and that should be held by schools that really want to engage in cross-border exchanges. The learning mobility should be a real possibility for any pupil in school education, and there should be a recognition of the learning outcomes of the mobility periods. So all these you should have in mind when you're writing your proposal. How to apply? You have to do it by 29th of October, midday Brussels time. That means that this Thursday. You can do it even if you haven't started. You have time to do it, but remember that it does take some time. So you should start immediately, or at least during this weekend, you should already take some time to start organizing your ideas. This is the link for your electronic application form. And remember that you're going to submit it to your own national agency. It doesn't have to be in English. You can see how, in which languages your national agency accepts your submissions. And once again, this is repeated, but you do need an organization ID. Who can apply in the field of school education? Schools providing general education at pre-primary, primary or secondary level, and local and regional public authorities, coordination bodies, and other organizations with a role in the school education field. So we are very near the submission deadline, 29th of October. There will be an evaluation period from November to February. The award decision will be in February, and by mid-February 2021, we should know if we were awarded or not. Remember that this is important for future Key Action 1 funding. That's why you should do it now. Just a quick look at the award criteria. Relevance can have a maximum of 10 points. So how relevant is your proposal? And then the objectives, 40 points, activities, 20 points, management, 30 points. So this is just for you to see that all of them are very important, especially the objectives. You should really aim to have a clear Erasmus plan regarding the objectives, but all of them are important. You need to have at least 70 out of the total 100 points and at least half of the maximum points in each of the 4 award criteria categories. Unfortunately, if there is too many applications, the national agency might set a maximum number of accreditations. I hope this doesn't happen, and that all of those that are at least the 70 out of 100 points will be awarded. As we said, this is valid until 27, but throughout the time you will need to report and to monitor, and they will ask you for reports and so on. So it's not that it's already valid until 27 and you don't have to show any work. You will have to show some work. And over here I have some useful links. I'm going to go through the application very quickly. So following this link, you go to opportunities and you can see here lots of information, the key actions. So if you don't know much about Erasmus, this is a good place. and accreditations.
Luisa, are you sharing the web page or because
oh,
we
I'm
just
sorry. I'm so sorry. Yes.
Yeah, we just see your PowerPoint. You have to share the full screen.
Yes, yes, yes. I know. I forgot. So where am I? I need to stop sharing, and I need to share over here. So I'm really sorry, but I followed the link that I showed in the PowerPoint, and I was over here. I don't want my applications, I want opportunities. And here's where you have lots of information for the application. If you go down here, accreditations, these are the different areas. I'm going to choose school education, okay? And you say apply. I'm going to create a new application. So on the left, there are all these parts of the application you need to fill in. And as long as it has an exclamation mark, it means that you haven't ended. There are guidelines. There are quite some information at each page, at each step that you go through. Over here, the context, for instance, you have to put the national agency, the language, if it's individual, if it's a mobility consortium. Over here, information about your applicant organization, the background of your organization. So you have to briefly describe what your organization is, what kind of school it is, what you have been doing, your main activities. So you have to describe a little bit of your own experience. And then you have the objectives, the activities. The objectives, you have here some information of how to fill in afterwards. So you should read this quite carefully to see what they feel is important for you to write about. And over here, you have these places to write all the information. So you have more objectives that you can put in. For all of them, you will need a title, explain them, when do you expect to see results, and how you're going to measure the process, the progress. So this is the part of the objectives. The activities, this is where you propose what kind of mobility. Is it summer schools? Is it job shadowing? What it is, and you should also have an idea of the number of staff that is going to each mobility, to each activity. So you have to describe that over here. The quality standards, over here you just have to agree. You should read it so that you understand the basic principles of the Erasmus quality standards. It's important for you to read it and not just to agree, because in the end they are going to ask you if you have read and you agree, because afterwards in the management, you should use what you read over here so that you can have a good management plan. And after you have all this filled in, there will be green marks over here. You can upload some documents, and you do have to upload a declaration of honor signed by the person in charge of your organization. And you have here checklists so that you really have to see if you have everything before you submit. So the guidelines, you can always read them over here. And where I was before coming here, which wasn't here, I was just going back to the PowerPoint just to open the application. Okay, over here, you can read a little bit about each section so that you know exactly what they want from you, and you can apply with the best information that you have and really targeting what they want. And I think that you can find their goals quite easily, so that you can write in agreement with that. So this was a very quick look at the application. Remember that you do need some time to write about your school and your Erasmus plan. So you should start it immediately, but you still have some time. In the links that I have in the PowerPoint, I put there a MOOC that is available until the 29th of October. I'm not sure if how good it is, but it might be quite interesting for you to look at it before you start applying. And I think that this is a very quick overview of the Erasmus Plus accreditation. I don't know if we have questions.
I don't see any question here. But thank you, Luisa. That was, as you say, a very quick information. I have to add to what Maria Luisa said, that the things that we have been covering this week about what are the needs of the school in terms of inclusion, digital skills, openness to community, everything is just in line with what Erasmus Plus is asking. So it's nothing new to you guys, and it's worth, even for those of you that are not from Europe, to take a look at the things that the European Commission is asking for applicant schools, because it's directly in line with the digital plan for 2021 to 2027. So I didn't hear the alarm clock. Yes, Luisa?
I have just a few questions. There it is.
But you go ahead.
It's just a couple of things. Someone asking me, they're teaching in a college in USA, and no, I don't think you can apply for the Erasmus. There's a question about the vocational program. Unfortunately, I don't have much time, and I don't know that much about the vocational program, but you can look at the page that I was showing before here, and over here you have lots of information. And I think that's it.
Thank you very much, Luisa, for this and covering this very important topic, especially for the schools that are in Europe. That means that if you feel that, and COVID allowing, in the future years, you can participate in some of the summer schools and winter schools and spring schools that we are running, and autumn schools like this one, maybe in a face-to-face opportunity. To the rest of the world, I think the plans are good as well, and we will be online for you. So this brings us to the final part, which is the questions, evaluation, future steps, and final remarks. And I will start by asking everyone, if you don't mind, to please click on this link that I have just shared with you, which is okay. I have Maria Luisa, you have all the thank yous there. I'm going to share again the link. We need you to please share with us. I think I'll give you 5 to 10 minutes for you to share your vision with us about your week with us. It's very important to us to know your view about your experience. So I ask you please to fill in this form, and we are going to give you, let's say, 10 minutes to answer this. It's a very simple form. You have to tell us name and email. It's optional, of course. You don't have to. The city is also optional. But then we want to know a little bit about you, your field of expertise, what the subjects that you teach, the grade levels that you teach, and what you consider about this training, some explanation about it. If you thought that this activity was good, so that you can share this with others. if the topics presented were interesting, if they were presented in a clear format, if they are useful for your teaching practice, so on and so forth. So it shouldn't take more than 7 to 10 minutes for you to fill in. So I will give you this time. In the meantime, if anyone has any question to Maria Luisa or to any of the other speakers that are still here, I will ask all the speakers to please turn on their videos so that people know that you are here, all the speakers that are here with us, because we don't have anyone sharing their videos. So Gustavo, Miguel, Luisa, Sandra, Naira, everybody, if you can just make yourselves visible so people know that we are here. We are your trainers for this week. Maybe in some future time you are going to be the trainers for us. And if you want, while you're, I'll be monitoring the numbers of responses that we are getting. And so we are here to answer your questions or to answer to your wishes. And for the trainers, if there's anything else that you want to share with the participants while they are filling in the form, go ahead, please. I think Beatriz, if you catch your breath already and you want to share anything, you told me that you wanted to share something.
It's already included in what you sent. Thank you.
There's a question from Mero asking, how long will the content from this course be on the platform, on the campus? And how do we access in the future? Okay, so the link that you have is eternal. It will never change. We don't intend to delete the things there. They will stay there until, the moment if Grasp goes offline, then there's nothing that we can do. I don't expect this to happen in the near future. As per so all the content that is there now, except for the recordings, they will remain there forever. In terms of the recordings, that I don't know. Michal, I defer that to you to answer about the recordings, how long they will be there. You're mute, Michal, you're mute.
Sorry. So the recording should be there for 1 more week, so that if you missed the session, that you can again watch it. And then in principle, for the moment, we have to take them down because we have not yet clarified all the administrative issues about recordings. You know, Rosa said it before, all this data right protection in Europe is a very serious issue, so we have to be very careful with those things. I hope that in the future we can have those things on our website so that you can simply connect and watch those talks, those very interesting talks, also in general without a time limit. And I'm just working now really to get the last presentations online to Grasp so that you can download those and use them in your classes. I'm just working on it now. I think there are not many missing.
Yeah, the same question again. The materials on Grasp will remain, they will stay there. The link again for the questionnaire, here you have. Let me know if you have any problem in coming in. You don't have any answer yet? Naira, Sandra, you have anything from the side of IAC to add? I don't think Fraser is here. You're there. Where are you, Fraser?
Well, I guess from our side that it was a pleasure to participate in this training. and to share with all of you these amazing talks. I really learned a lot, and I'm gonna look at all the videos that I couldn't attend because I had trainings to be informed of everything. And from my side, thank you so much for joining. I don't know if my colleague Naira wants to say something else. No, just the same as you, Sandra, that it was a pleasure to be here. For me, it was the same. I was also doing this week several other things and couldn't attend some of the sessions, but next week I will be there watching everything. And thanks a lot for the full team because I think it has been great. It has been a fantastic experience. David is also there. I don't know, and I think he and all the team were doing a very good job. But I think Michel and Bea are going to say this later. Thanks a lot to all the participants also for being with us this week. That it has been an intensive but very, very, very interesting one. And that's all from my side. Thanks a lot.
I think I can speak from the side of Núcleo. I have here the members of my team that helped, Luisa, Teresa, Gustavo. Ana is not here with us, but she also was a big help. Everyone doing its part. And it worked perfectly. Thank you very much for everyone to the support. I think this training weeks with the European Space Agency have been a blessing, the highlight of my year every year, because it's just to me it feels like, okay, this is exactly what I want to do, with bring cutting edge research to the hands of teachers and students and make them understand that space is not far away, something that is just for the top-notch bright people. It's for everyone. Everyone can have their hands on. And yes, there are bright people there, but the world is not made of giant steps. They're made of steps of normal people doing their work every day. And I love this opportunity to be with this team of people and bring the teachers together so that the world of the students becomes big, universal, special, spatial. So I have to thank in particular Beatriz and Miguel for the opportunity to join hands with you guys. It's really a privilege. I think it's the 10th or the 11th. I don't know how many years we've been doing this, but this one is very special. And as you could see, we have a team here with the IAC and with Fraser in the National Schools Observatory, Folks Telescope. I think it's a super team that I really hope doesn't go away. We are achieving a lot and learning a lot from each other. And it's a dream team from my point of view. So from the bottom of my heart, and to David and Diego and everyone that made this come true, and all the teachers that spent so many hours with us, knowing that you were teaching, some of you in the middle of the night and doing the work, and you did stay with us. And I from the bottom, really bottom of the heart, thank you very much for making this dream come true. I hope you come back every year.
Yeah, with this, I cannot add anything in because everything was said. So it's exactly that. It was again an amazing experience. We have to. It was the first time that we did this online. It was an enormous experience that we could participate in the Canary Islands course in July, which gave me much more confidence that we can do it. And it worked out really very well. And I can just say again, many thanks to everybody who participated. It would not have been possible without the help of everybody. And again, as Rosa said, many thanks for you who were connecting every day, at least for some time, to be directly with us online. It's not easy to spend the whole week just on one thing. We will repeat this for sure, and I hope to see you all
So I see the responses slowly coming, but I would like to give the floor to the teachers. Is there anything that you would like to add, to say, to ask, any wish that you would like to see come true for the next courses? Anything that you would like to share with your colleagues? Maybe, Gustavo, you can share again the link to the WhatsApp group if they want to join and be able to communicate with their colleagues. There's someone again asking if the material will remain on Graph. Yes, and the link is eternal. It will not change. The material will remain there, except for the recordings. There's someone saying, muito obrigada, see you next year. That is very good. We already have clients for next year, Michal.
Fraser is complaining about his beer.
Fraser, you're supposed to behave in front of everyone.
Yeah, next year we will see. On one hand, I really hope that the COVID situation will get better and we can do a course really receiving participants on site at the European Space Astronomy Center. But on the other hand, even if we do that, I think either we have to combine the presential course with the online course, or we have to do another online course, because I think it gives the possibility to many more people to participate, because online it's much easier to organize, it's less expensive, you don't have to travel, and you can reach many more people than in the classical form.
Yeah, someone said here, the only COVID blessing was that these things moved online, and so we can reach out to people all over the world. This was something that I didn't foresee. It actually is something very good.
I wanted to say, sorry, because before I didn't have much to add, but I want to say that this was a dream, as you were saying, Rosa. We all made it together, the dream team. And I also would like if Elisa and Diego can open the cameras. I don't know whether they are visible or not, because they were also in the backside helping the team. So thanks a lot to all of you, and it was a great experience. I will repeat it again together if you want.
There's a good idea here. Marina is asking that the next time we give the floor for them to share the projects that they do in their school. That's a very good idea to include in the next program, something that we usually do in the face-to-face events, but we didn't remember this time. Thank you, Marina. That's actually a very good idea. So we have 15 answers to the questionnaire still, lots to come. I will ask Anna to also send to everyone via email, so people have the possibility. So please, people, do fill in the form. We do need your feedback so that we know, it's important that it's again design thinking. We need to know our client. If you're satisfied, you will tell us there. It's anonymous if you don't want to give us your name, and we really know what we have to improve so we can make a better work. And if you really loved it, just give 5 to us to everything, and next year we don't have to prepare, we just make a copy of Grasp and that it is. I'm joking, there's always a lot to prepare because there is a lot of new science to be done every year. So that's a very good thing and a very good challenge for us. So Michal, if they don't have anything else to say, and if the team here is, I think everyone is pretty tired, don't have anything else to share, maybe you have the final word and you can close the program officially.
Yeah, many things. I can only repeat what I said before. It was an amazing experience. It worked out really very well. As it was said in the comments, so we turned a problematic situation into an opportunity and managed to get something very positive out of it. So it's a new approach. So we will plan for the future many more courses in this way online. So we will be able to reach many more people. And this will also help us to build up a kind of educational community focused on space applications. And I hope with that, I will see you at the next course that we organize in that format. And then there's no excuse because we've demonstrated that it works online.
It really did. It really did. It was an amazing sharing opportunity. So I think that's it. We will miss you all. I hope that you all join the WhatsApp. So in between courses, we have a sense that things are happening right there. Thanks a lot for the dream team. And I think that's it.
Yeah. See you next time. Bye.
See you all next time.
Bye-bye.
See you soon.
Bye.
Bye.
Bye. Thank you.
Bye. Ciao.
Bye. Ciao.
Bye.
Ciao,
Yeah.
grazie.
Bye bye.
A mi non so, mi volia fare tutto questo percorso. A mi em pare presuntuosa, ma